start at 6:05. Okay. So
Okay,
that
okay,
most of
okay.
our
Yeah.
participants will join by 6:05.
Okay. So do we have a break in between? And so what will be the timings like?
Sir, first session is from 6 to 7:30. Then we can have a 1 minute break. Then
Hello,
we
hello,
can
sir.
continue till 9. 1 minute or 2 minutes according to your convenience. We can give a break.
Okay, 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 okay. Yes, yes, yes. Okay, okay. So will do.
So we will start with a prayer. Okay.
Yes. Yes, madam.
പ്രപഞ്ചം നിറയുന്ന ദിവ്യ ചൈതന്യമേ, പ്രഭാതത്തിലെങ്ങും നിറയും പ്രകാശമേ, ബുദ്ധിയായി സിദ്ധിയായി ആത്മചൈതന്യമായി വിദ്യയായി ഞങ്ങളിൽ എന്നും നിറയണേ. നന്മയും സത്യവും ധർമ്മവും നീതിയും സ്നേഹവും ഭൂമിയിൽ എന്നും പുലരണേ. സ്നേഹവും ഭൂമിയിൽ എന്നും പുലരണേ. സ്നേഹവും ഭൂമിയിൽ എന്നും പുലരണേ.
Good evening, everyone. It is my pleasure to welcome you all to the fourth day of this enriching faculty development program. Over the past few days, we have delved deep into various aspects of our theme, gaining valuable insights and perspectives. Today, we are privileged to have with us an esteemed academician and expert in the field of artificial intelligence, Dr. Sumodh Sundar. Dr. Sumodh Sundar is currently serving as Associate Professor and HOD in charge at the Center for Artificial Intelligence, TKM College of Engineering, Kollam. A distinguished academician and researcher, he holds a PhD in Artificial Intelligence in Medical Image Diagnosis from VIT Vellore and an MTech from TKM College of Engineering. His passion for continuous learning is evident as he is currently pursuing a part-time postdoctoral at KTU and an MBA at IGNOU. With an extensive background in AI, machine learning, and deep learning, Dr. Sumodh Sundar is a corporate and ASAP certified trainer who has conducted over 70 sessions in AICTE and KTU sponsored FDPs and workshops. His research extends far beyond academia, trained more than 3,500 professionals, employees, and students. Apart from his impactful teaching and training, Dr. Sumodh Sundar is also an accomplished author, having penned a textbook on computer programming and published research papers in reputed science in AI entities and startups. Beyond his academic contributions, he has played significant professional organizations. He served as academic relations of IEEE Kerala Young Professionals and is currently the treasurer. His online session on data science earned him a place in the Indian Book of Records. It was recognized with the Best Faculty Award in 2016. With such an illustrious profile, we are truly honored to have Dr. Sumodh Sundar with us today. On behalf of PISAT and the delegates of AICTE Adult Faculty Development Program, we wholeheartedly welcome you, sir, to this faculty development program of fourth day, seventh session. Welcome you, sir.
Right, right. Okay. So thank you, sir. Sir, is it audible? Audible, like,
Yes, sir.
can you tell me, like, am I audible?
Yes, sir.
Yes,
You are
sir.
audible.
Yes.
Hello? Am I audible? Can anyone?
Yes, sir. You are audible.
Yes, yes. Okay, okay. So let me start this session. Before that, hope you could see me, right? So hi everyone. Good evening. Yes, yes. Okay, okay. So good evening, everyone. I think we have wonderful participants in and around Kerala and outside from Kerala also, right? Okay. Okay. So I think, sir, it will take some little bit of, we have some lag, right, in between. And also, I think it's audible to you. I feel ഞാൻ സംസാരത്തിന് ശേഷം കുറച്ച് കഴിഞ്ഞിട്ടാണ് റെസ്പോൺസ് വരുന്നത്. Right. Okay. Okay. So let me start the session. And before that, I should express my thanks to the organizers, especially the management of ISAT and the organizers and my esteemed faculties and friends over there. Right. So we have wonderful faculties and participants from various places of India. Right. And let me start the session. And the main disadvantage of the online session is that we couldn't interact with properly. Right. So if we are communicating in an online session or offline session, we could see you directly. Right. So within that limitation, we could continue this session for the next 3 hours. Okay. So hope you are all get ready for this session, right? And I think you have some wonderful experts for the last few days, right? So today I'm joining with you to discuss about convolutional neural network, right? And let's start this session. Before that, I think that you have some expertise or you have some knowledge in neural networks before, right? And before getting into my session, I should say that you should have some basic knowledge in machine learning, and you should have some basic understanding in neural network, so that I could jump directly to deep learning. Normally, I convey the workshops, like I conduct the workshops. First, I will start from basic machine learning, and then I will carry out deep learning. Then I will jump to CNN. In that way, I'm carrying the classes, right? And and I think you are before that. Yeah, can you mute yourself, everyone, please? So I think you are all aware with the machine learning techniques, right? So my humble request to the participants is that I know that you're all engaged in multiple ways, but can you engage with me in chat box? Hi everyone. Can I know that what is your expertise in machine learning? I know, or in deep learning. Can you chat me, like, I think around we have 200 participants around. Yes. Can you tell me, like, what's your stage? Like, are you a beginner or an intermediate or an expert? A beginner, intermediate, or expert? Can you chat me? Can you chat in the chat box, everyone? I'm waiting for your chats. I think we could interact properly for the next 3 hours. I think otherwise it will be some boring sessions, right? Can you chat me in the chat box? What is your status? Like, are you beginner or intermediate or expert in deep learning? Yeah, Tanushree Tapa, hi. I think you are a beginner, right? Yeah. Can anyone? Yes, beginner. Straight time, right, right. You should intermediate, right? Okay, Renchita, thank you for your responses, beginner. I think we will have some interactive session. Otherwise, it will be getting boring, right? Yes, beginner, Vasantara, beginner, Shenbagam, beginner. Yes, 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 yes. Yeah, I think you have some beginner. You are already having beginner experience in deep learning. Very good, very good. Deepali intermediate, right? Okay, fine. So I think most of us are all from CSE background also, right? Yes. Okay, okay. Thank you for your response. And what about your knowledge in machine learning? Can you tell me what is your knowledge in machine learning? What is your knowledge in machine learning, or a beginner or intermediate or expert? I think intermediate, what I consider is like you have tried out something, few things, right? Okay, everything you are all spelling out like beginners, right? Okay, okay. So I expect the chat, you continuously chat with me in the chat box, okay? And otherwise you could give me some voices also in between, okay? So let me start this session. Okay, okay. Yes, okay. Thank you for your responses, actually. So otherwise, one-side communication is very boring, right? Okay, okay. So let me start this session. Before that, here, right, I will ask some questions in between also. You please respond, okay? So here you see that. So prerequisite should be you should have some knowledge in machine learning and neural network. So let me start sharing the screen. So everyone, please mute yourself, okay? Yes. Yes, I hope you could see my screen, right? Okay. So let's start from here. we are going to discuss about convolutional neural networks. And before that, you should know the basics of neural network as well as the basics of machine learning. Okay. So let me open my screen mobile phone also so that I could chat with you. Okay. That I will be able to chat. Give me 1 second. Okay. So I will ask some questions in between. Please respond me. Okay. So I hope you could enjoy with the session with me. Give me 1 second. Okay, all right. So let's start from here. So convolutional neural networks, right? So does anyone doing PhD in this deep learning area? Can you chat me? Anyone doing research or PhD in this area, CNN? Can you chat me? Anyone doing PhD or research in CNN or deep learning? Anything? Can you chat me? I'm waiting for a chat boxes. So this is my disadvantage of my session. I will ask questions in between. So please chat me properly, please. Anyone doing PhD or research in CNN? Anyone? No responses. Divya, ma'am, are you there? Am I audible?
Yes, sir, you are audible.
Right, right. Lag illalo. Lag illalo. Continuously കേൾക്കാൻ പറ്റുന്നുണ്ടല്ലോ അല്ലേ?
Yes, sir. Now you're audible.
Right.
Yes, sir.
Yes. Okay, okay, okay. Thank you. So let me start this session with CNN, right? So hopefully you have an understanding of neural network and as well as the machine learning techniques. So why we coming to convolutional neural networks? That's the idea behind before getting into this topic. And before that, hope you understand with these topics, right? So hope you know about machine learning, right? So in machine learning, you know that we have various techniques like supervised learning is there, unsupervised learning is there, reinforcement learning is there. And can anyone tell me the difference between supervised and unsupervised learning? Because we should know CNN belonging to which class of task, right? So can anyone tell me or chat me like what's the difference between supervised learning and unsupervised learning? Can anyone tell me what's the difference between supervised? Hope you got an idea. In the last sessions you have attended various topics, right? So can you tell me what is the difference between supervised? Can anyone? Or in the chat box or some, can you give some audio? Difference between supervised learning and unsupervised learning? Yeah, right, Nitya, thank you. Training is there in supervised. Yeah, training is also there in unsupervised, but can you spell out the exact difference between, in the case of data, when we are training, we should provide some data, right? So can you give me some idea of data? Yeah, Iron Prime is giving, everyone is giving, yes, thank you. I always expect this kind of responses. In supervised learning, we are working on some trained labels, data with the labels, and in the case of unsupervised learning, there is no labels. And coming to supervised learning, you know that various tasks there, like classification and prediction belonging to supervised learning, where classification, you know that, right? For example, we have 50 images of cat and which is labeled as cat, and 50 images of dog and which is labeled, right? And total 100 images of animals are there, so which is labeled either as cat or dog. And this process is called, so we are working on the labeled data, and this phase is called training. And you know that two phases are there, training and testing is there. And in training phase, we are labeling the data. And in the testing phase, after training this data using these 50 images of cat and 50 images of dog, and we are, after the training phase, there comes the testing phase, in which we are giving a new image to the camera so that the camera or the model will recognize whether it is a cat or dog, right? This is called a classification. And this is not the case of, classification is not for the case of images only. This is applicable for audio data. For example, we are there training some voices or audio, you know that Udit Narayanan is there, right? Udit Narayanan, we are taking some audio files or music of Udit Narayanan and we make it labeled it as Udit Narayanan, right? And 50 audio of Shreya Ghoshal we are taking and we are labeling it as Shreya Ghoshal. And this process, 50 images of Udit Narayanan, sorry, 50 audio of Udit Narayanan and 50 audio of Shreya Ghoshal. We train the model, and when we are giving the new set of audio, we are labeling it as identifying it as which is the exact label we should assign for the new song, right? That is called a classification, right? And coming to the prediction, you could see that. See, this is all about like predicting a future value, right? Predicting a future value in the sense when you're playing the cricket matches and you are watching the TV, right? And you can see that after 40 overs, we will be predicting the new score, right? If the Indian team players are playing in this way, what will be the score they are scoring, right? So that will be the case of prediction. So predicting the upcoming value is called a prediction, right? So we have some image, we have some temperatures from January to November, and with these January to November temperatures, we are predicting the temperature of December. So that is kind of a prediction, right? So hope you got the difference between classification and a prediction, right? And this belonging to supervised learning, and coming to clustering is actually grouping up of data. It's something entirely different from the classification and prediction techniques. What is clustering actually? So clustering is all about grouping up of data based on the similarity. For example, we have in the case of admission, you know that when the first year admission goes on, you can say that the students from various parts of our district or state are randomly sitting in classrooms or auditorium, and they are randomly sitting, right? So they don't have any groups between them because they are coming to the college for the first time. But after 3 or 4 years, we could see that the students are sitting in groups in their classes because they will understand the rapport between them, and they will understand who are all the people matching their vibe, right? And they will be sitting in clusters after fourth year, right? Perfect clusters we could find out. So similarly, how clustering we could define is like we could. So that is called clustering actually, right? So that's a case of clustering. So coming to association, you know that these are all victims. I know that everyone has smartphone and everyone might be having Facebook, and definitely you are having Instagram, right? So you can see that most of them are using Flipkart and Amazon, right? Flipkart and Amazon, and in Flipkart and Amazon, you could see that whenever we are going through Flipkart and Amazon, and sometimes we will be purchasing some product, otherwise just we will go through all these products and randomly looking into the prices, and we will leave out from there, right? And you can see that once we leave out from Amazon or Flipkart and coming to the Instagram, and you can see what we could see after coming from Instagram, after coming from Flipkart and Amazon. Can you find out something special in Instagram? Can anyone spell out what is it? So once we reach to Instagram, can anyone tell me what we are seeing there, like in Instagram? We can see some advertisements, right? Ads happening in the, yeah, recommendations, exactly, recommendation. Suppose you are purchasing or looking the prices of some shoes or shirts in Amazon. When you are reaching to Instagram, you could see that some predictions are happening. So this, you can, everything is happening because of the data what we give to the this kind of apps, right? So if you are going to YouTube or Facebook also, you could getting some recommendations of YouTube videos based on our previous history. You will be getting some a recommendation of friends in Facebook based on the mutual friends or the closest. So this kind of recommendation we could classify or group into association. And you could see that, yeah, supervised learning, we could have classification, and hope you got the difference between classification and prediction and the difference between the clustering and association. Is that correct, right? So why I'm telling it explicitly, because we should know in which task the classification or the CNN belonging to, right? So can anyone tell me, like we are going to teach or study today all also about CNN, and either CNN is a classification task or a prediction task or a clustering task. Can anyone tell me? CNN is a classification task or a prediction or a clustering task? Can anyone tell me? Yes, it's a classification task. Exactly. So this is a classification task. So we are going to discover how the CNN is performing classification, right? Let's see. So you know that supervised learning is data which is labeled properly, right? But in unsupervised learning data, it's not properly labeled, right? And coming to when we are dealing images, we should know that See, an images will be given to the model, and the model is all about to do some task, right? So, for example, one of kind of the task is like classification, right? So classification is all about, for example, I have 50 images of cat and 50 images of dog, which is trained into a computer, and that algorithm we could call task. Actually, it's a model like. So every time when I'm spelling about model, you should think that it's an algorithm. Okay. So please remember that CNN is a model. That means CNN is an algorithm which you are going to train. So cat, for example, I'm training the model. I mean, training the CNN algorithm using 50 images of cats actually and 50 images of dog. So totally we have 100 images of cat and dog, right? So when I train the model with this 50 images of cat and 50 images of dog, that process is called a training. And when I'm giving a new image, when I'm giving a new image into the model will identify, right, whether it is a cat or a dog. Is that so, right? It will be like that. So hope you got an idea of classification, right? For example, I have 50 images of apples and 50 images of oranges, and I'm training into the oranges, which I'm training into the model. And after the training, in the testing phase, when we are giving the new fruit, it should predict. It will be either as a orange or an apple, right? So my question to my dear participants that, for example, my question, please listen to my question. Imagine I am training the model using 50 images of cat, okay, or training the model using 50 images of dog actually. So 50 images of cat is there, 50 images of dog is there, right? So this phase is called a training. But in the testing phase, I'm giving the images of a tiger, image of a tiger. So my question is like, what it will go into predict actually? So options I'm giving: option A cat, option B dog is there, option C tiger, option D error. Okay, so I'm training the models using cat and training the model using dog. But in the testing phase, I mean, the model is now able to recognize the cat as well as the dog, right? But in the testing phase, I'm giving the picture of a tiger to be recognized. Okay, so what will be the answer like? What will the model? What the model will be predicting like? So option A cat, option B dog, option C tiger, option D error. Can anyone tell me? I'm expecting your answers in the chat box actually. Can you tell me? Okay, option A is here. Okay, somebody is saying tiger, somebody is telling error, somebody is telling cat, and somebody is telling cat. Okay. So okay, I'm reading your chats actually. Options are cat, dog, tiger, error. Okay. Okay, somebody is giving some answers like error, right? So we will be thinking that it will be giving some error. But I will stand with the answer like it has the most chance to predict as a cat actually. What is the reason behind that? What is the reason behind that? Okay, for example, I'm not telling it badly. Like for example, if you're training 50 images of a boy or 50 images of a girl, and in the training phase we are giving 50 boys and 50 girls, right? But and labeled it as boy either right as a girl, right? But in the testing phase, for example, I'm not saying it badly. Like I'm giving the image of a transgender. Can you tell me what will be the answer? Maybe is it going to predict as an error? Is it going to predict as an error? It will be predicting as either man or woman, right? Like similarly, because when we are giving the image of tiger, it will look into the similarity which is closer to cat as well as either as a dog, right? So the tiger will be similarity to cat, so that it will predict as tiger only, right? So similarly, when we are giving, sorry, it will be giving cat only, right? So when we are giving a transgender photo, it will be looking to predict it as a boy or a girl because we are trained with the boys or girls. So the images which are closely look like some transgenders are look like boys and some transgenders are looking like girls. Okay, so that will be based on similarity. So hope you got an idea regarding classification, right? So here another task is like localization. So once we have classified the model, we could localize it. I mean, we could spell out or look into the area where it is located. So that is called localization. So we could generate the anchor boxes or something using the localization method, right? And coming to the this is all about discussing about single object, right? So coming to the case of object detection, for example, in a single image, there will be the presence of some multiple objects are there. So we could spell out identify which are all the objects present in that area, right? So that's cat or dog or that. And hope you got an idea of detection, right? And today we are not going to discuss about detection. We could discuss about segmentation actually. So segmentation is like you could see that. So for example, a brain cancer. in a brain cancer image, you could, brain cancer. For example, some brain areas are very good, some dark area will be there and the gray cells are there. But in the case of a cancer affected patient, the thickness or the intensity of the dark color is very high. That if you're looking into that area, that dark color is very intense. The dark color is very intense. So that intense area, we could cluster it together. And that process is called a segmentation. Okay. And that we call the semantic segmentation is there and instant segmentation is there. So semantic segmentation is all about grouping about the similar objects. Like, so you could see the cat, dog, cat, this will be similar. But if you are going for semantic segmentation, it will look for the entire area. I mean, that will not segregate the background behind. So that is semantic segmentation. And similar to cancer area we've spot on, that task is called a segmentation. So hope you got an idea what is classification, detection, segmentation, right? And you could see that in deep learning techniques, and you know what is the difference between machine learning? Can anyone tell me what is the difference between machine learning and deep learning? Can you chat me? You have attended the few classes previously, right? Can you tell me what is the difference between machine learning and deep learning?
So in machine learning, we use more of statistics, and deep learning we use neural nets. So it actually
Oh,
overcomes the limitation of machine learning.
yeah, right. Yeah, that's a very good answer actually. And can you tell me what about the feature extraction? Difference of feature extraction in both these techniques?
Yes. In ML, feature extraction has been done before, but in deep
Yes,
learning, it is part of the network. The feature extraction is
exactly.
within the network.
Yes, exactly. So in deep learning, the features will be automatically extracted. I mean, the layers are responsible to do that. Very good. So you can see that in classification, CNN is a very good model, and various kind of CNN variants are there. I hope you heard about Inception net is there, VGG net is there, Alex net is there, Rust net is there, right? So many nets are there, right? Have you heard about that? If you have used or heard about previously, can you chat me? Yes, like I will be reading your chats. Okay. So have you heard about that kind of networks? Alex net is there, VGG net, Rust net 50, lot of kind of Inception net is there, right? So this kind of models are we going to use for a classification. But in the case of detection, there are some techniques like RCNN is there, fast CNN is there, and fast RCNN as well as YOLO also is there, right? So these kind of algorithms we could use it for detection purpose. Okay, a detection purpose we could use it. Okay, and some kind of segmentation techniques. For example, in medical imaging, there are some segmentation technique called unit is there, and various modifications of unit are there, right? Everyone is modifying unit and training it for their own purpose. Okay, and some kind of modification is called VNet also there. So these are all the kind of architectures we are using for some classification detection. I hope it's clear, right? So jumping to CNN, why we are using CNN and what are the theory and layers behind CNN, and later we will be doing some hands-on in MNS, because why I picked it, because this will give you some basic understanding of the layers what we are using CNN. So along with the CNN explanation, I will show the hands-on part also, so that every beginner can try out, so that I can do some coding in MNS data set. Okay, also. So I thought to show some classification on another data set. For example, plant classification. Plant classification is there actually. So different kind of leaf. Sorry, not plant. Exactly the leaf classification. Initially I thought to show the difference or hands-on on that, but it will take some lot of time to. I will share the codes later. Okay, so that you can try it later. So today this is our agenda for that. Okay. So shall we start? Like, right. So I hope you could see that this one, right? So this is a case when we are seeing an image. Okay. Okay. So please everyone get ready for starting the session. So you could see that this is an image, right? And you could see that this is how computer sees an image, and you should know how it will be exactly processed, like this one. And every image is showing it is in the is a way of matrix format. Okay. Matrix in the sense means you could see that you know that the primary colors are red, green, and blue, right? So the red metric is there, green metric is there, and blue metric is there, right? So you could see that when we are seeing an image, this will be a combination of this RGB, right? RGB is there, right? RGB combination is there, right? So hope you could see that it's a metric actually. You know that every image, the metric is associated. For example, if you are going to Instagram and you are selecting a filter to enhance your beauty or increase your saturation or some kind of techniques you are using, right? So when we are applying these kind of techniques, actually we are multiplying a matrix with another matrix to produce a new matrix. That the new matrix are shown to you, like, so that you will be seeing that my beauty is increased, right? So similarly, every image of processing operations, the behind is like the matrix operations are there. So the understanding is like for an image, it is represented as an RGB matrix, right? R matrix, G matrix is there, and Blow matrix is there. Is that okay? Fine. Hope you got that, right? And you know about neural networks. I'm not going to depth in that because you already know that, right? If I'm telling about neural networks in detail, it will take another 1 hour to complete that, right? So I'm continuing with the hope that you are all aware with the neural network, right? So for example, you know that this is a neural network and you can see that multiple layers are there, right? So initially we have some input layers and in between hidden layers and you know about this concept, right? Before that, we should start from perceptron, the concept of perceptron. In perceptron, you should know that in a perceptron, it consists of multiple inputs coming in, and the inputs are coming along with the weight, and inputs are multiplied with weight, right? So after that, we will be applying some activation function to produce the output what we are actually firing, right? So you know the concept of the basic perceptron, right? So similarly, we are having multiple layers, so that for example, in the first layer, we are having 1, 2, 3, 4, 5, 5 layers are there, 5 neurons are there, right? In 5 neurons, actually, we are giving 5 inputs. So it will be propagated, and each and every neurons are connected to the multiple neurons in different layers, right? So that weights are adjusted in between, so that the output layer will be emitting the exact output, right? So this is in the case of deep neural network. But when we're treating with a deep, for example, for the input image for the neural network, I'm training it with some images. But in the case of neural network, when we are dealing with the images, it will take more computation, right? Because for example, I have an image with 200 into 200, it will be go through each and every pixels, and even though you could see that 28 into 23 8 into 3 pixels means what is the value? 200 into 200 into 3 means I think it's around 2 into 2 4, and 40,000 into 3 12,000 is there, right? No, 1,20,000 is there, right? So you can see it's there, right? So initially, we should make the number of neurons in the initial layer to be 1,20,000. So it is a complex task, right? So this is the reason behind when we are not we are if we are having a huge data, we are not dealing with the normal deep neural network directly, right? So this is the reason. Hope you got that, right? So when we are dealing with the images, for example, this is a data. For example, 2 is a digit actually. So in 2, you could see that for example, my the digit 2 is expressed as a 7 by 7 grid. You know that 7 rows and 7 columns are there. And oftenly you could see that how these values are coming, right? And you know that the values are written between 0 to 250. Okay. So I will explain what is the difference between binary image, what is the difference with the grayscale image, and otherwise the color image. 3 kind of images we could specifically say is like binary image is there, and the grayscale image there, and the colored image is there, right? So I will explain what is the difference all these kind of images, right? So you could see that here, this is an image 2, right? So if where the 2 we are going to write, this will be like this one, right? So this area having some pixel value, that means this area contain the digits of 2, right? So that the pixel values are higher in that area. And the remaining area, for example, the black area, you could see that the value is 0. So you could see that if I want 0, 0, 0, 0, 0, 0, 0, 0, 87, right? So I could say that this is a 7 by 7 grid, and you know the total value is 49, right? And I am flattening it as a 49 neuron net in this manner. 49, right? It's a 49 kind of network. For that, those who are already aware about neural network, you know that this is an input neural network, right? But in the case of input neural network, if it is a case of a 49 neurons here, you should know that this neurons are in total number of values of 49 neurons should be there in the first layer, right? And what about the number of layers? So what about the number of layers in the output neuron? Can anyone tell me? This is the case of input layer. This is the case of input layer, and this is the case of output layer, right? So can anyone tell me why? What is the number of neurons there in output layer? What is the number of neurons in the output layer? What is the number of layers in the output neuron? Can anyone tell me? Yeah, now we have 10 neurons. Can anyone tell what is the criteria behind that? 10 neurons. Can anyone tell me the reason behind number of neurons in the output layer? Can anyone tell me? Now, for the example, we have 10 neurons, right? Can anyone tell me how much neurons we require? Yeah, it's 0 to 9. 0 to 9. Can anyone tell me the reason? Yeah, for each digit we have one class, right? For each digit we have one class, right? So, for example, I need to classify, my classification task is like I need to classify into 10 classes, right? 10 classes. So we need to label from 0 to 9. So the number of neurons in the last layer, it's all about the number of classes, okay? So please note it down. So number of classes. For example, my task is to classify the data into boys or girls, okay? Boys or girls. So now what is the number of classes there? I'm categorizing either it as a boy or a girl. So can anyone tell me how many number of classes are there? How many number of classes are there? How much number of classes are there? Can anyone tell me? I'm doing yeah, 2 classes are there, right? So in output layer, there should be 2 neurons, right? Is that clear? Output layer, there will be 2 neurons, right? So for example, I'm classifying the data into 3 classes. The number of layers in the output neuron should be 3, right? And I have some conditions like about what out about the activation function. Sigmoid is there, so let it be there. So hope you got an idea, right? So this is a challenge we should take care when we are dealing with some images, because for example, this is a black and white image, and we have multiple neurons in there. And see here, you can see that the 9 is there, right? So sometimes the 9 will be appear in different parts of the image, right? So might be this is a full image, and you could see that 9 is there in some parts, like so that the presence is indicated by 1 and the absence is indicated by -1, right? So that which is shown in here, right? And you could see that here also you could see that here also we could see that the presence of the image will be in different parts, right? So that area we should identify properly, right? So here you could see that this is an image of koala. It's a kind of it's an animal, right? This is an image of koala. I'm taking it for your knowledge purpose, and you could see that the image is of dimension. Let it be the image. The dimension is 1920. The width size, and the height size is 1080. Okay. And what is this 3? Can anyone tell me what this 3 indicates? What this 3 indicates? Can anyone tell me what is the reason behind that 3 actually? RGB is there, right? RGB. So I should, for the beginners, I should take care about, I'm going to explain about these 3 things. See, these kind of images I will show you. Actually, you should know that the beginner should know, should know about this one, right? For example, I will show you here. I will show you here 3 kind of images I should take. I can show you, exhibit to you, right? Okay, can you see my screen, right? So for example, I have an image. For example, I have an image with a dimension. Let it be, I have 3 set of images. Okay, 3 set of images. Let it be like 1, 2, and 3. So 3 set of images, and let it be the dimension is 224 into 224. Okay, 224 into 224. Let it be 224 into 224, and I could say that this 224 into 224 into 1, 224 into 224 into 1, and I will say that this is a black and white image. Okay, this is a black and white image. So what is it? What is the idea behind black and white images? And you could see that we have you could see that multiple values are there, and 224 rows are there, and 224 columns are there. I'm showing text like a 3 by 3, but you could see that the pixel values will be 0 and 1, right? So every pixel value, for example, some pixels will be 0 and some pixels will be 1, right? So you could see that. So in black and white images, you could see that the pixel values are filled with zeros and ones only. And please take care that the channel, this is length and this is width and this is channel, right? So the channel is 1. Okay, the channel is 1 actually, right? And coming to grayscale image. Okay, coming to grayscale image. Okay, there is another kind of image. So I know that some already you know the concept, right? The grayscale image, and you could say that I'm telling that this is also 224 into 224 into 1 actually. Okay, 224 into by, I mean, there is no channel depth actually. There is no channels, right? And you could see that here also. You could see when you are looking into the number of pixels, it will be a value between 0 to 255. Okay, it will be values between, when we are looking into the area, some values are like 220, 34 is there, 210 is there, right? So you could see that. So you see multiple values are there, right? So I'm not going to write, I'm just not showing in random way, I'm writing in. So hope you got an idea between this one, right? And coming to the third one, I'm going to discuss about the coloring. So coloring, because they should know about this concept, because today we are going to train the CNN based on this. Okay, I will show the difference also. And here also, but coming to the depth, I would say that it's not 224 into 224, it is 224 into, can anyone tell me the dimension what I'm going to type here? 224 into 224 into, I have already told that. What is the dimension of that color? Yeah, exactly. 3 because when you're dealing with the colored images, it will be like in a 3-layered format, right? So I know that somebody is already knowing the concept because for the beginners only, I'm right. Okay. So just I will quickly show this because we have this kind of patches here, right? You could know that. Can anyone please mute yourself? Everyone, please mute yourself, please. So you could see that here you could say that it will be 3-layer structure. It will be like this. Okay. So R component is there and G component is there and the blue component is there, right? So it will be a metric like this. So this is RG, right? This is RG. This is RG. Can you please show that? No. So can you chat me like, hope you got an idea and the values of the color, values of the pixel, it will be 0 to 255, right? So you can see. So hope you got the difference between this black and white, a grayscale and colored image, right? So in black and white, the pixels will be 0, 1, and in grayscale, it will be 0 to 250, and colored, it will be 0 to 250, right? And yeah, can you hear me now? Can somebody's can you mute yourself? Somebody is giving some disturbance there. I will increase my sound here. Okay. Sir, can you mute them? Someone is giving some voice. Okay. Can you mute them, please? Organizers, please mute them, please. Okay. So hope you do. Can you chat me like? Hope you got the difference between black and white, grayscale, and color. Can you chat me in the chat box? Is that fine? The beginners? Yes, right. Because we should know the concept behind before training. Yes. So that yeah. Okay. So when we are taking the when we are taking the colored images, it will be looking like this, right? So you can see that, yeah, images having 1920 in 2018 to 3 means we have a 3-channel representation because it's a colored image. For example, if I'm training it with a normal neural network, okay, initially you know that we need to flatten. Flatten means we have a 1099, 1080 width and 3 channels. So once we flatten this, it will be like a matrix multiplication, right? So it will be 6 million, around 6 million data. I mean, neural network in the initial layer, that kind of, not that much of neurons we record in the initial layer. So that is a very, 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 very complex situation, right? So that we should take care about this kind of situation. So this is a case when you know that these are all digits of X and 0, right? But you should know the differences, right? This is X and this is O, and O may be appearing in different parts of the images, right? So we will be able to distinguish this one. That's the question actually. So because the X will be, for example, if I'm taking my selfie, sometime I will be in the closer to the border area, sometime I will be to the center area. It will be entirely different, right? So we should take care of all these things together. So when we are taking the image of koala, actually, you know that some features are required to recognize these kind of animal. For example, you can see that when we are taking the koala eye and the koala nose and the koala ear is there, so it will identify that this is a head portion, right? So we should take care about the head and the legs so that the body portion is there, right? Body portion is there. So when we are taking the head and the body together, we should know that this is the koala. So this is a fundamental idea behind how the CNN recognize a model and making into the right set of predictions. Is that okay? So we require some kind of analysis in between. You could see that to recognize that this digit is a 9, actually we should take care about the loopy pattern. I mean, we should take care that, yeah, for identifying this is a loopy pattern, this loop should be there and a vertical line should be there and there is a diagonal is there actually. So this is very much required to segregate the different parts of the image which is belonging, right? So you could see that, and you could say that this is very important. Yeah, 1 second. You know that once we have this loopy pattern, vertical line and diagonal only, we are able to identify that this is the digit 9 actually, right? So this is very required. Okay. So coming to this one. 1 second. Yeah, here you could see that the loopy pattern might be appear in different parts of the image actually, right? Sometimes loopy pattern is there and sometimes loopy pattern is there. And you could say that vertical line is also there, right? So it's a vertical pattern, right? And this is a diagonal pattern. And we should know that loopy pattern and a vertical line and diagonal line should be properly identified that and it should be distinguished to identify this digit is 9 properly. Okay, this one. And this is a challenging cases because we should take care that whether it is X or 0. Okay. So we'll be whether it is be able to distinguish in between. That's the question actually. So let's take a black and white image. It may contain some. So we should be comparing this comment of mine. So this way we are required CNN in which CNN should be able to identify the exact neurons because and also you have already seen that the then connected layer neural network is there and each you can see that multiple neural networks are there, right? Multiple networks are there. It is very challenging to process in between using these kind of networks, right? Because the weight updations are very much high to distinguish these kind of things, right? And you could see that when we're dealing with the CNN, it will look only to the exact picture. So hereby I'm starting the CNN. So please note it down if you're a beginner for the first time. So are you writing with me or okay, after my first session, you should take care. You should do hands-on session with me actually. Okay, you should properly do hands-on session with me. Okay, please do that. So hope you're aware with the Google Colab as well, right? In Google Colab we are doing the hands-on, right? Okay. So these are all the layers associated with the CNN convolution layer. Are you taking the notes? Can you chat me? Are you taking your notes? Because I need to place the face of my session, how I should proceed. Okay. Okay. So you please take a convolution layer, a relief layer, a pooling layer, and fully connected layer. Okay. So these are all the prominent major layers of CNN. Major layers of CNN. Yes, right. So when we are giving you or train the images using X and O, the model will understand, yeah, this is X and hope you got that. And how CNN will roughly do that like this way, because it will looking for the pixel matches actually, but is it able to compare this one? That's a question behind that. So you can see that this 1 - 1 - 1 is there, and but it is here in the second image. We couldn't look when we are looking at the same location. We couldn't place an exact match, right? So it will be triggering out to some other locations, right? So this is the reason behind that. Okay. So how CNN will look like that? In image processing techniques or electronics, people know that, right? It will move from one place to another and it will find out the exact matches, right? So this is the process we are going to look into now. So which will look for the features or the patches actually. Okay, so let's see how it look like. So these are all the pictures I have taken from the internet actually. So you could see that when you're training the data when you're training the model CNN using some kind of images, and at the end it should be able to recognize whether it is a car or a truck or a bicycle, right? Because we are going to train the model using this kind of images, 10 set of images, car, truck or bicycle. Right? So finally we will be recognizing at the end, right? So you could see that here, you could see that. So how many classes are there? 10 classes are there. And you can see that in between, we are placing the layers actually. The convolution and relief layer is there, pooling layer is there. Again, I'm placing a convolution and relief and pooling is there, right? So at the end, there is some layers are called a flattened layer and fully connected layer. And finally, we are placing some softmax layer, okay, detailing. So that we are going to discover now, right? So hope you got an idea. And please take care or please note it down. And this phase we will call it as feature learning. And this phase is called the feature learning. So in this phase, when we are going through all these kind of layers, we are extracting the features basically. And once we extracted the features, that features will be fed into the classification mainly. Okay. And this process is called a classification. And this phase. So because after when we are passing the images through these layers, and you could see that you'll be flattening the entire result into a single layer, right? You could take it as a vector out of there actually. You could take it as a vector out of there, and that vector I could say that it's a feature matrix actually. So that is exactly the feature matrix representation of the image what we trained there, right? So that is the feature matrix over there, right? So using that feature matrix actually we are passing into some neurons and finally predicting some results actually. So that is a difference between the normal machine learning and the CNN or a deep learning concept. Hope you got an idea, right? So after that CNN, you can take care about the concept called a transfer learning. In transfer learning is all about using the features which is extracted from the previous feature learning process. And I mean, some dedicated networks are there, AlexNet, VGGNet, RustNet is there, and we could use that output vector. We will call it as weight actually. So the weights are we going to train, and finally we will be resulting the result. So let it be there. So this is the idea behind that. So please take care this one. Okay. So we have some CNN layers. So once we extract the features from there, and we are giving the features into the classification model. Okay, so let it be there, and so we could start from here. So let's start CNN basically now. You could see that the convolution layer is there, relief layer is there, pooling layer is there, fully connected layer is there, right? So shall we start the operations of each and every layer? I know that in YouTube videos and some kind of network, some kind of tutorials, you will be aware about convolution layer. But actually, what I'm going to discuss is like I'm teaching the MTech students. I will be getting into some details. I mean specifically. Okay, I will be giving some information in detail. Okay, so is that okay? You will be getting some mathematics because I have read the specific textbooks of CNN and I have got that idea because I have gone through each and every lines. Okay, so let it be there, and so you got some extra information from this session also. So let's start from the convolution layer. Of course, you could start from, you can see that in CNN, you could see that we are training the model, right? We are training the model. For example, I have 1,000 images. Okay, 1,000 images in the sense, for example, I have 10 classes, car, truck, bicycle, aeroplane. So 10 classes are there. And for each and every classes, we have 10 images. So how many data are there? 10 into 10, 100 is there, right? So you could see that each and every classes, we have 10 set of images. So we should be training the model using this 10 into 10. For example, every class we are having 10 images, and for every, so totally how many images? 100 images are there, right? So every classes we have 10 images. So right side we have 10 classes also. So we are training the model using these 100 images, right? So we are making the CNN to recognize or memorize these features of this 10 into 10. So for example, this is a convolution layer you are having, and how it is performing the convolution operation is like, in electronics, you have already seen that what is convolution operation. So for performing the convolution operation, given set of image you are seeing in the left side, and another set of image you are seeing in the right side, and that is called, I will show you actually what it look like. So you can see that this is the image, this is the image, and this is the filter. Okay, this is the filter. Okay, this is the image and this is the filter, and you can see that this is a 3x3 filter. Okay, this is a 3x3 filter. So the decision of the number of filters is all about the experimentation. Okay, because it depends upon the data set and the topic we are going to discuss. I mean the domain what we are selecting, right? So it depends upon actually the data set. Okay. So you could see that convolution layer how it's going to process like. So we have an image on the left side, and you can see that this is the image, right? So for example, the image is of dimension 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, right? So 7 into 5 is the image size, and you can see that this is a filter with a dimension 3. So how it performs? Can anyone tell me how it works like? So actually in convolution operation, for example, I'm placing the filter to the top of this image, okay, to the top of this image, to the top of this image. So how it looks like is like each and every pixels are, for example, 1 into 1, it is multiplied, right? So you know that 1 into 1. Okay, so 1 into 1 is there, and plus the second set of pixels is there. So 1 into 1 is there, right? So 1 into 1 is there. You could see that, right? 1 into 1. So how many? So now we have seen two multiplications there. So can you tell me how many such multiplications will be there totally? How many such multiplications will be there totally? Can you tell me if I'm taking a 3x3 filter and I'm placing it at the top of the image? So how many multiplications? Yeah, 9 multiplications there. And that 9, yeah, thank you for your chats actually. Okay, so that 9 multiplications are happening, and we'll be adding to that, right? So finally, the added value is placed here actually. You can see that added value is placed here actually. So this is minus 0.11, but hope you got that right. So minus 0.11. So hope you got the idea. Everyone got the idea, right? So this is the idea behind that. And second one, what we are going to do is next we will be moving the filter to the next location, right? Next we'll be moving to the filter to the next location, right? This one, this location I'm moving, right? So you could see that. Now I could tell that this filter we have moved from left to right for the one movement, right? Only one movement we are giving, right? Just we pass to the next location, right? So this one, and again the matrix multiplication is happening, right? So 1 into 1 is there, 1 into 1 is there, 1 into 1 is there, and totally we are having 9 multiplications, right? So the 9 multiplications are added together, and we'll be summating and we'll be writing over here, right? Writing will be here, right? And similarly, then what we'll be doing for the next day? We will be moving to the slide to the right immediately to one position to the right side, right? So that additions we'll be having, and we will be placing it here, right? So this one will be happen. So hope you got an idea, right? Is that okay? We are moving from left to right, right? In a fashion, right? So once we move from left to right, this will be jumping to the next set of, we will be coming to the next immediate, I mean, one movement to the bottom, right? One movement to the bottom. And you could say that again, it will be multiplying together and it will be generating the value over here, right? So similarly, this will be repeated again and again. So left to right, left to right, left to right, one to the bottom, one to the bottom, one to the bottom, and finally we will be getting this one, right? So this is the feature map here generating. So dear participants, is that okay? So finally we'll be reaching here, right? That slide will move from left to right, bottom, 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 and finally we'll be reaching to the last position, last 3 by 3 position. So and dear participants, is that okay? How hope you got an idea how this feature map is generated? Is that okay? Can you chat me? Is that clear? So once I go to your chats and I'll be clear to that. You're aware of that, right? Yes, right? Okay. Can you note down there? Can you note down there in your notebook how the C and convolution layer working happen? So we will be explaining the modifications actually. Okay. We will be explaining the modifications. Yes, right. So hope you got it right. So this how the convolution layer working properly, right? So this is the operation. You can note it down in this way: AW plus BX plus. You may note it down. Okay, I will be giving you 1 minute for you for making your writing. So please write this way. So this is a picture I have taken from the textbook. Okay, this is a standard textbook. I will show you that. So please remember me that remember that please the textbook link I could show there, right? Okay. So please note it down. Okay, are you writing there? Can anyone yes or no? Because I need to look into the next part. Yes, you're writing, right? Okay. Okay, so hope you got this, right? You might be writing this, right? Okay, can you jump to the next part? Yes, yes. Okay. I'm reading your chats. Okay, every chat I'm reading. Okay. So moving to the next part. So why the requirement of why this requirement of convolution layer? You should know this properly. Okay, I'm taking these pictures from internet actually. So why you require this one? Why you require this one is actually 1 second. Okay, so why we require convolution layer is there to detect, because to recognize that the computer should recognize that the model should recognize that this is a digit 9, right? And you could see that there are some to identify that this is a digit 9. You should take care that you should know that yeah, this is some loopy areas are there, right? Some loopy areas here, right? Some loopy areas are right. So to recognize the loopy area, you could see that yeah, this is a loop identification filter, right? This is a loop identification. Here also it's a loop identification because that area filter, filter you could see that you know about filter, right? That this one, what the matrix what we are going to multiply with the image is the filter, right? Here you could see that there should be loop detection pattern. Here also there should be loop. And you can see that what's the difference between this identifying 9 and 6 at the same time? Because 9 have loop, 9 have diagonal, 9 have vertical line, right? Similarly, 6 also having loop, vertical and diagonal, right? How to recognize these are all different actually, right? So can you spell out how it's going to different? Here you could see that once we matrix the matrix of 9, sorry, once we multiply the matrix of 9 with this one, you could see that the multiplied results emit some value and summation might be 1, right? So that will be having the value 1 and it will be into the top here, right? It will be top here. The same matrix we are going to multiply with the pixel values of 6. You could see that the output will be here only, right? Output will be here only. So similarly, 8 also, some multiple loopy patterns are required, and hope you now it's not a wonder that here you will be getting some 1 and some 1 will be here, right? What about an image may contain 96, right? There is a film called a 96, right? So 96 is there, and you could see that when it moves, so 96 an image. So for example, if the filter is moving from left to right, left to right, left to right, left to right, you could see that the multiplication will happen. The loopy pattern will emit some value because the multiplied will value the loopy. For example, this is a loopy pattern, you know that, right? So once we multiply the loopy pattern over the images, you will be sporting out some one here and one over here, right? You can see that, right? You can see that, right? So this is the, sorry, okay, this is the identification, the requirement of that having this convolution layer, right? Is that okay? Is that okay? Is that clear, right? Why we require the convolution layer specifically? I know that I should just explain convolution layer and show the matrix multiplication, but you should know how actually, how it will help us actually. Okay. So I'm explaining the relevance of that filter specifically. Okay. And here you can see that, for example, the case of the Koila detector, two eyes are there for Koila, right? So because the eye detector, let it be some random kind of values will be there, and I'm not going to tell specifically what it will be like, and it will be moving from left to right, and you could see that whenever we are passing the filter through that eye part, it will be emitting some one here, right? So here also it will be one here, right? Similarly, so here, like, the position of that Koila eye will be in different parts, right? So it will be in different parts, right? And here you can see that multiple eyes are there, right? And group of Koila is there, right? So you can see that multiple. So similarly, for example, we are identifying. So please take care. This, please hear it very carefully. We need to find a filter or a matrix that I'm calling it as a detector now. We need to find or a filter or a matrix specifically so that that kind of filter should be able to identify that kind of speeches. So that's why I'm mapping it with the Koala. For example, this detector, we should identify the values properly so that that filter values are able to recognize the eyes specifically. Okay, that will emit the higher value, right? So is that clear? I mean, I'm specifically explaining the relevance of having these kind of filter values. Okay, that's the main point. So this is my conclusion. Like, we should be identify the right set of filter values to identify the right set of values. So here also hands detector is there, and you could see that to identify a 9, there should be a loopy pattern recognizer. There should be a vertical line recognizer. So in the vertical line, you can see that that value will be occupied with 1, and there should be a diagonal line detector. So you could see that to identify the 9, there should be a loopy pattern detector, vertical line detector, and a diagonal line detector is there, right? So that these three will be clubbed together so that it will be recognizing that this digit is a 9. Hope you got the relevance of the detector. Hope you got the detector, in the other ways we will call it as features, right? I mean the metrics what we are going to multiply. Is that okay? So that's the relevance of that features property. Okay. So hope you got an idea. Is that okay? Can you share me the relevance of having multiple features? I have in this example, I have shown you how a single feature matrix is multiplying with a single image and generating an output, right? Now this 1 minus in the green color indicates that this is a filter. This is a feature. Okay, this is a feature matrix. This is a filter values we are having. Now I am telling that the relevance of having multiple features. Is that okay? Multiple filters, multiple 3 by 3 filters or some kind of dimensions are there, right? So is that okay to having the relevance of having these kind of multiple features? Because I'm going to show you the code, and at that time I will be having some mathematical notations also. I'm not going to boring you. Okay. So hope you got the idea, right? So once we have that, we could identify the images properly. Okay. Is that clear, dear participants? So my question is that point number 1, is that clear that if we have a filter and once you multiply this filter with an image, what is the output going to produce? And point number 2, is that clear that the relevance of having multiple features, right? So we need to identify these kind of features. So that is the idea behind. So the idea behind CNN is to find. So it might be we will be having multiple. Sometimes instead of this 1 minus 1, we could give some another set of values, right? So in this place we could have some values like this one. So this value is one. These values are there, right? Sometimes this kind of values are there. So this is not enough to identify loopy pattern. Okay, this is not enough to identify loopy pattern. So to get a loopy pattern, the loopy pattern value should be like this, right? So this is the job of the algorithm or CNN. So what we are going to show is in there we are going to show in the keras or TensorFlow. Hope you heard about keras and TensorFlow, right? So in keras and TensorFlow, we are going to train the data set, and there we are going to write the CNN using keras and TensorFlow. And upon each and every iteration, okay, each and every iteration, we are finding the right set of values. Okay, so after each and every iteration, we are looking for the best set of values, right? For example, we have some students in our classes, right? And we are aiming, for example, a student called Arvind. Okay, we are expecting he's a topper of the class, and we are expecting out of 100, we are expecting 98. So we will be expecting that he will be getting 98 marks for the exam, series exam or internal exam. But when the exam results came, the marks are 90. Marks are 90. So you can see that, yeah, we are expecting 98 and we are getting 90 only. Is that okay? Is that enough? There's a difference that 8 marks difference is there, right? So you know that 98 minus 98 is the target value, 90 is the obtained value, right? So the difference between the target and obtained we will call as error. The difference is called error. So we know that, yeah, he has some personal issues in life and will be having some depression issues, or he has some mental issues, or have some personally affected issues. So we'll be giving some personal consideration, and we will be giving another set of chance, and the next exam we are giving a retest. So he is now in the initial phase, he are getting 90%, 90 marks. Now he has scored 95 marks. Okay, when we are giving some retest, and you could see that initially we are expecting 98, but we are getting 90 only, means that the weight or the features, you can see that the features there, right? 111, 1 minus 1, 111. That is the actual features values we record, actual filter values we record for classifying it as a 9. Okay, for recognizing it as a 9, this loopy pattern filter should be equipped with these values. So sometime initially when we are training the model or CNN model, might be we are not getting an accuracy only 90% only. Okay, because the reason is that there is, for example, this is a filter it is generating. So initially the filter might be like this value. Okay, so when we are training a model using this filter, it is not able to recognize the loopy pattern, and finally it will not be able to recognize the value 9, right? So coming up of this filter value to this filter value, okay, coming up from this filter value to this filter value is called training accuracy. Okay, so I could say that I have reached the maximum accuracy because upon it, for example, I will be reaching this matrix or to this matrix only after 10 iteration. Okay, 10 iteration only. Okay, 10 iteration only. So that I could say that, yeah, after 10 iteration, I got 99% accuracy. How I am going to tell that I am getting 90% accuracy? Because I have reached the right set of filter. Okay, so please listen, my dear participants. I am explaining the contents for the last 1 hour, but please take the next line. What I'm going to explain, what we do in CNN training. Everyone is telling that I'm training CNN. Okay, what we do in CNN training is that we are finding the right set of filter values. Okay, we are initially we'll be starting with some random filter values, and after each and every iteration and epoch, we will be finding the right set of filter values. So that's the aim of CNN. So that is the aim of the training. So that at the end of the training, we will be finding the right set of features, and we will be classifying it properly. Is that okay? So hope you got an idea, right? So that's the. So can you chat me? This is a very important point actually. We need to identify the right set of features. Can you chat me? So that is the aim of the training basically, because we need to identify the right set of filters, and that will be make able to. So hope you got an idea.
Is it the right set of filters or right set of features?
I mean, right set of filter values. This
Filter
values.
values.
Yes,
So
filter.
we start off with the initial random values for those filters, or we have some predefined filters there?
Yeah, we can do the training in multiple ways, so that some random initialization is there, zero initialization is there, some glorot and this kind of 3 or 4 techniques are there actually. Okay, so these kind of initialization techniques we could give, so that we could mention the training that, yeah, this is the initial set of values we could. So either way we could do in multiple ways. Okay, so randomly start with some random values basically. Okay, glorot initialization is there, key initialization is there. Okay, we could do it. Okay,
understood.
Okay. So hope you got the idea of having the right set of features. Okay, so let me jump to the next part actually. So hope you got that. Is it clear that how to fix the size of the filter? So it determines, yeah. One question from Dr. Is there actually how to fix the size of the layer? There is a technique. So you know that we are not experts actually. We require the number of filters, number of epoch. I will explain now. You please listen that filter and sorry, iterations and epochs are same. Okay, but there is a clear-cut difference between iteration and epoch. Okay, the number of iteration, the number of or the size of the filter, and how many number of filters, that I will show you now. How many number of filters, right? So these kind of things we could do by using trial and error experiment is one kind of technique, because we could trial and experiment over various, and we could start from, I could say that, yeah, train this model for 10 epoch. Okay, train this model for 10 iteration. For batch size, you take 32 or 64. For the size of it, some random values we could give some random value and make the model to be trained. But there's a decent technique or a standard technique called hyperparameter tuning. Okay, hyperparameter tuning is so in hyperparameter tuning, we will be giving some set of options like number of iteration this much, number of models this. I mean, optimizer. There's a concept called optimizer actually. Okay, so in our syllabus we have one module option for optimizer itself. Okay, because that much of topic is there, right? We have enough content in optimizer that is beyond of my scope today, a topic today actually. Okay, let it be there. And so my question is like, my answer is like, so we need to take care what is the number of filter, number of layer, number of size of the filter, number of optimizer. So that is a technique called hyperparameter tuning, in which we are giving the right set of, we will be getting different options, and out of these options the model itself will going through each and every combinations, and finally will predict, will take care of the which are the right set of parameters. The model itself will find it. Okay, so that's the idea behind. Is that okay? To the queries you have placed in the chat box, how to fix up the size and what is the number of iteration. What is iteration means actually, in the previous classes you might be heard about weight updation, right? Back propagation is there, right? I initially told that you should have a basic knowledge about back propagation network. Okay, in back propagation network we are training the weight actually. Okay, so each and every iteration we are updating the weights. Okay, basically, so weights in the sense in CNN it's very clear that, yeah, this is, please consider this topic as a new sequel of a, not as a sequel of a new movie. I mean, you don't need to as a prequel. Okay, prequel part. Okay, I mean the previous classes. Now you take a, we need to update the weights after different iteration. I mean, the number of iterations. I mean, each and every steps we are updating. So please take that iteration is almost. So let it be there, and hope you got that what is convolution there, right? So this is the idea behind convolution there. Okay, so let it be there, and the convolution and the relevance of convolution there. Okay, so please take it, and I am going to show you how exactly it is calculated. I am telling you that I am taking you to the next part actually. So hope you got what is convolution look like, right? So please take it. Okay, 1 second. I will show you the next part. Okay. So is that okay? Now we started the convolution there. I'm going to depth how the convolution there is going to work. Is that okay? Right. So shall we start? Can you take a breath and come back to the topic again? I think by 7:30 we'll be taking some breaks in between. Okay, let it be there. Okay. Okay, I think now you are hearing me for the last 1.5 hours. Not 1 hour, right? So we will take a break. Not, this is not break mentioned by the coordinators. I'm giving you some other break. I mean, you can take your eyes from your screen off. Okay, we'll be holding your 1 minute. We can take a break. Please don't go somewhere. Okay, okay, you can take a break quickly now. Okay, I know that you are continuously watching into the screen, right? Your eyes are getting struggled, right? Okay. Yes, shall we do start? We'll take a break, okay. So before that, a small. Okay, so let me start again. So please listen from here. Please get ready. That I know that you are getting bored. Okay, so please get ready. Okay. So when I'm taking the machine learning sessions, I will be continuously explaining my stories and continuously explain supervised learning and supervised learning, various applications are there. And I'm doing workshops in machine learning. At that time, I will be easily engaging all these sessions with it's some interesting examples. Okay, but in the case of deep learning and CNN, the session is purely technical. Okay, so that might be you feeling some boring. Like, okay, so here you could see that, right? So let me start the session. Okay, so please listen from here. I'm going to explain a concept here. For example, please take a, so please give me some answers. Okay, you could see that image is here. The image is here. This is 224 into 224 into 224 into 224. Okay, so you can write it later, and I will give you some idea. Okay, 224 into 224. Here, you could see that the filter. I am going to multiplication is 3 by 3. Okay, 224 into 224 into 3. So once I do the matrix multiplication, once I do this matrix multiplication, what will be the output dimension? That's my question. Okay, once I do this matrix multiplication, what will be my output result? Can you tell me the dimension? Can you tell me the dimension properly? Once I multiply with the 224 into 224 along with the 3 by 3, can you tell me the dimension what we are going to explain, what we are going receiving at the end? Can you chat me, anyone? Please don't look into ChatGPT or Google, okay? So initially I have an image 224 into 224. I have a filter size 3 by 3. What will be the dimension when I multiply this? You know that this filter will, move in this way, right? Left to right and left to right, right? So here left to right, left to right, left to right is will go in this fashion, right? It will go in this fashion, right? So can you tell me what will be the dimension at the end of this one? Can anyone chat me? You are there, right? Yeah, we have 290 participants, right? So can you tell me? Hope you are listening me, right? Not looking into TV just by switching on the Google Meet. Can anyone tell me the answer? Once we perform, this is a convolution operation, right? This is a convolution operation, right? This is a convolution operator, right? Convolution operation. So the answer will be, okay, the answer will be 221. Okay, 221 into 221. So there is an equation called output size is equal to input minus f plus 1 is there. Okay, input minus f plus 1 is there, right? So you could say that the input minus 1 is equal to 224 minus 3 plus 1. 224 minus 3 plus 1, right? So it is 222 actually, right? Sorry, 222. So 222, right? So this you could say that this 224 is there and this 224, right? 224 into, and once you have that, right? So please change this. This is 222 into, yeah, 222, right? 222. And similarly, the second 224 and second 3 will make it as 222. Is that clear, everyone? This is a first phase. I'm making telling that this is a first. Please consider this is case 1. Okay, this is case 1 actually. Okay, case 1. Hope you got that idea, right? And then next one, I'm expanding it further. Okay, next, you please tell me the answer. Okay, can anyone, is that okay, right? You can tell me the answer. Okay, 222 into 222 here, right? 222 into 222. Okay, so you can tell that you got an idea, right? How it will be look like. Okay, and the second case I'm going to show is like 224 into 224. And 1 second, I will show you. And when we are doing the hands-on, you can see some practical examples over there. And there is a concept called a padding. There's a concept called a padding. Okay, there's a concept called a padding. I mean, you have already shown seen that how the convolution layer works like. So what is the need of padding? Then you can see that when we move the filter from left to right, from top to bottom, right, left to right, and top to bottom, you can see that when we move from some rows, see here it is repeating, right? Here it is repeating, right? This 1 by 3 and this 1 by 3 is moving from left to right, and you can see that this when I'm placing this 3 by 3 first here, and when I move from left to right, and you can see that this set of pixel values are not repeating, right? This set of pixel values are not repeating, right? You can see that, right? So similarly from move, I mean not repeating means it is encountering for only one time, right? So when we move from left to right, and you can see that these pixel values are also not repeating, right, in the multiplication. Is that okay? Can you chat me yes or no? Is that clear? Can you chat me, please? Chat me. Is that okay? Only that pixels are repeating only for the first time. Okay, only first. Is that okay? Yes. And when we are moving to the bottom, the same thing happens, right? Here 3 by 3 is there, and 3 by 3 is there. Here it is repeating, and finally you could say that I'm giving a statement. Can you agree with me? Like, this row, this column, and this column, and this row and the bottom row, it's repeating only for single time, right? It's repeating, it's less repeating comparing with the other one, right? It's less repeating with that. And imagine when I'm taking a selfie, I might be appearing in the border part, right? I might be appearing in the border part. Border part in the sense means sometimes the precious, I mean the sensitive the values or the sensitive image parts are might be locating at the border of that image, right? Sometimes I'm taking a selfie, I will be appearing into the border part, right? So there's a chance of lose that values, right? So is that okay? Hope you got the idea, right? Sometimes the sensitive information might be appearing. So to avoid that, to without losing that, there is a concept called padding. There's a concept called padding in which we are adding some extra pixels, I mean zeros, to the border area, right? So I'm giving the padding is equal to 1, so that only one row and one column is equipped with this value, right? I could give a padding of 2, so that the 2 rows and 2 columns will be able. Is that okay? So that once we add that padding, so it's an optional one, okay? So zero padding is there, right? So we could fill the padding with other set of values actually. Zero padding, instead of padding, we are having some other value. So in that pad, when we add the padding, you can see that it will be looking like this one, this one, this one. Now the images are equipped with the padding in this manner. So initially image is in this manner, and now it is added with the padding, right? Is that clear? So if I'm adding padding, so this is the case, right? If I'm adding padding is an optional one. So what will be the dimension again? Okay. Now you have seen that the calculation is calculated in this manner, input minus f plus 1 only, right? So if I'm adding a padding is equal to 1 also, I mean you can add an extra border to here, and you can spell out, you can add the pixel values in the border regions here, right? You can see that, right? Okay. So for example, if I'm adding a padding, okay, let it be there, and here with the padding and without padding is there, right? You know that with padding is here, right? For example, if I have a padding is equal to 1 also, padding is equal to 1, padding is equal to 1, what will be the output dimension again? What will be the output dimension again? Okay, can anyone tell me what will be the output dimension? Here also there is an equation. Yeah, I got some answers in the chat box. So there is an equation like output is equal to input minus f plus 2p plus 1. This is the equation. Hope you're writing this one, right? Hope you're taking the notes there, right? You're taking the notes. Okay. So now you find out the equation 224 minus 3 plus 2 into 1 is 2, right? And plus 1 is there, right? So what is the value? 221, 223, 221 plus 3, right? 224 is the answer, right? So 224 into 224. Is that clear, dear participants? Somebody is giving an answer 223, right? So 224 into 224. Dear participants, can you chat me? Is that clear to you? The equation. So this is the case when we are having the padding, right? Yes, because see, sometimes some textbooks are the contents are there, right? But most of the textbooks are not providing these concepts. Okay, so it's there in textbooks, but please take this one. Okay, I will be getting some much more detail in the case 2 case. Okay, second case. Okay, so this is the case when we are having the padding. Okay, so dear participants, is that okay? So can I move to the next one, next idea? Can I give some next idea? So initially we have seen that without padding, and now we have seen that with the padding. Okay, without padding and with the padding, right? Without padding and with padding. Now I'm going to show you like see, is a case of a normal situation, and here you could see that I'm see. Can you listen to me? I'm going to explain. Okay, you can see that when I am applying a multiplication or sorry, when I am applying a filter, it will move from left to right, 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 right? So you can see that, for example, this is the initial area where I have placed on. After multiplication, it will jump or move immediately to one location to right, right? Then we will shift one location to the right, right? Is that okay? But on the other way, when we are multiplying after multiplication, I could jump to the next 2 locations, right? After, I mean, I could use a stride of 2, right? I could use a stride of 2. Are you confusing? I get confused. Like, so for example, we have a set of pixels here, set of pixels here, set of pixels here, right? So we have some matrix over here. So for example, if there is a matrix, and after multiplying this one, I'm moving to the 1, 2. Here I am placing 1, 2. Here I am placing. The bottom also 1, 2. Here I am placing 1, 2. Is that okay? So that time, if I am taking two movements left to right or a bottom part, I will say that stride is equal to, okay, stride is equal to. And here there is equation. If I am applying some stride also, here I am applying some stride also to the normal case. I mean, you can see that this is a normal case, this is a normal case, and this is where I'm padding is applied. And here also, in the normal case, I'm applying the stride. So if I'm applying the normal case in the stride, the equation will be looked as in this way. OP is equal to input plus F and divided by plus 1 is there. Okay, plus 1 is there, but divided by, there is one more concept called divided by S is there, right? S is there. Now you could calculate, right? Now you could calculate what I am explaining, right? So this is the case when we apply the stride. Okay, now you could calculate that. Initially, in the previous example, can you tell me, can you chat me? If so, what will be the stride here? Can you tell me in the chat box? If you are understood, you will be answering here. In this case, what will be the stride size? In the initial symbol case, I'm moving from left to right and top to bottom one by one. What will be the stride size there? No one is there. In the normal symbol case, what is the stride size? I'm giving you the hint. I'm moving from left to right and top to bottom one by one. I'm moving from left to right and top to bottom one by one. The filter is moving from left to. So what will be the stride size? Can you chat? No one is there. Initially, the stride size will be 1, right? Yeah. So here you could see that. Now the equation will be input minus F plus S in this way, right? This is the equation when we are applying the stride. Okay. So for example, if I am having the stride 2, yes, I am dividing into the 2. So in the previous case, the S is equal to 1. So there is no change in equation, right? Is that okay? When the case is stride is equal to. Is that clear? Can you chat me? Okay. And the final case is like I'm going to the very detailed part, right? And the case when both the stride and padding is there, okay, and the equation will be OP is equal to input minus F plus TP, and along with that we are having this yes, okay, along with that we are having this yes, okay, along with that we are having this yes, we are having this yes, okay, and plus 1 we are adding here. So please note it down, this equation. So this is a case when we are, so this is a final equation we need to take care. Okay, this is a final equation. The output layer will be emitting this value, input minus F plus 2P by S plus 1. So we could decide the number of padding, we could have the number of stride, and so you will be taking, so for example, padding is equal to 1, stride is equal to, calculate the output value. So please do along with me. 224 minus 3 plus 2p, 2 into 1, 2, and the final equation 1, and divided by 2 is there, right? So in this manner, we are calculating this equation. So here I could say that, so can you tell me the final value? The final value is like 224 minus 3, 221 plus 221 plus 223 by 2. But you can see that some decimal error there, right? 223 by 2. Can you tell me the answer? Because some cases yeah, we should take care about when what is how will you take care in the decimal. Okay, so can you tell me the answer? 224 minus 3 plus 2 1 223 by 2. What is that decimal value? Can anyone? It should be 223 by 2. What's the value? 223 by 2. 111.5, right? Yes, plus 1. We should express in decimal, and plus 1, it's equal to 112.5. So in basically, we are taking the floor value. So that will be having 112. Okay. So please take it, this will be the output value. 112. There will be a confusion that we are going for floor value or seal value. We are taking the floor value. Okay. So this is 112, and the final output dimension will be 112 into 112 into 112. Okay. So this will be the final output. So please take care that this is the equation to generate an output map when we have some padding value or some slide value given a filter size over a set of image, okay, on an image. Is that okay? So I think you have got an idea. So what we are going to explain on the next is like, is it clear? Can you chat me this equation, this one finest equation, which I marked in red color? Is that clear to you? Is that okay? Right. So once we have that, we will be jumping. The next part is like, what will be the addition when we are having point number one, if we are dealing with a 3-channel depth. Okay. And the another addition, what will be the idea when we are having, we are mentioning about 3x3 filter, right? So if we are having 32 such 3x3 filters, what will be the output dimension? So these are all the cases next we are going to discuss, right? So this, I think you need an immediate break now because you are hearing this boring session for the last 1.5 hour, right? So now, because you should take, I'm going, see, those who are attended the CNN, you might be have heard about from YouTube or some YouTube or some lectures or tutorial, but I'm going the depth in detail. I mean, because how it works like in through some mathematical equation. Somebody already know this concept. So once we have that, I will express this how what will be the output, and then we will get express relief pooling there. It will go for some fast way, and after that, this thorough knowledge will be jumping into the hands-on part also. Okay, so I think even though it is a boring session, you will be got some idea from this session, right? How the convolution works, right? So is that okay? Can we proceed in this way? So if it was in a machine learning session, I will be, I mean, I will be, if in an offline also, will be engaging. Okay. So I think it's clear to you now so far. And can we take a break now? Can we take it for 5 minutes? Okay. Now we have 7:35, and can we join it? We could join it back by 7:40. Okay. Is that okay? Right. Okay. Thank you. We will be joined back by 7:40. Thank you. So, dear participants, can you hear me? Shall we continue? Like,
Yes.
okay, right. So it's audible, right? It's an audible and clear too, right? Okay. So, okay, fine. Thank you. So I think we could continue our session and yeah, right. Thank you. I'm reading it. So main motivation of my session is your continuous chats, okay? So that you know the difficulty of having these online sessions, right? So your chats only making me, okay, I think have a network issue. Let me reconnect. Okay. Okay, I think it's clear too, right? Okay, I think I have some network issues. Okay, I think it's clear too, right? Okay. Can you, sorry again for disturbing you. Okay. Can you, someone, right? Can you hear me? And is that clear? Divya ma'am? Yeah, okay, right. Fine. Okay, thank you. Right. So we were discussing about CNN, right? So we have seen a phase that once we have an image and once we have a filter size, we'll be knowing that what will be the output which is multiplying, right? Output which you are obtaining based on the execution, right? Input minus F plus TP, and this is. So this is the case we have seen when 224 into 224 is there, right? 224 into 224 is there and 3 by 3. So let me explain how it is going to, I mean, grow like so this normally I take the classes in this way because so that everyone give an understanding that what will be the next phase. Okay, so here I am repeating the topic again. For example, this time we are having the convolution layer. This we are having that image, and you for example I'm taking this image here. Okay, so here this we are having this image, and again I have a 3 by 3. Again I am having a 3 by 3 here, right? Okay, 3 by 3, 3 by 3 here. Okay, and finally, once we multiply these three, these two, this one, and finally we'll be multiplying and we'll be getting. Now again
Screen
will
is
be
not
repeated.
visible in sir.
Oh, okay. Sorry. Okay. Now you could see me, right? See my screen, right? Now you can see me, right? Okay.
Yes, sir. Thank you, sir.
Okay, it's clear, right? So what we have explained is like the image is there and we multiplied with the 3 by, okay, thank you. 3 by 3 is there and now you have seen that image. Now we are going to explain again a 224 and 3 by 3, but this time you know that this one is, so please take it 224 into 224, 3 by 3, right? But this time what I am going to explain is like this one. 224 into 224 into initially I mentioned about this binary grayscale and colored image. You got an idea, right? So this time we are having 224 into 224 into 3. So what will be the output? What happens there, right? So that is the idea we need to take and get. Okay. So here you have it. You need to have 3 by 3, right? 3 by 3. And now I can mention it's like 3 by 3 by 3, right? What I'm going to explain is like, let it be 3 by 3, 3 by 3, 3 by 3. What I'm going to explain is like, here 224 into 224 into 3. Now, what is the difference between 224 into 224, normal 224 into 224 with the 224 into 224, 3? You can see that here you could see that add-on layers are there, right? So add-on layers are there, right? So you have add-on layers, you have layers in between, you have layers in between the in this manner. Okay, in this manner we are having, sorry once. The difficulty in having the PPT, right? If you are having classroom boards, yeah, 224, let me try. Okay, 224 into, yeah, 224 into 3 is there, right? So you are having, sorry for this figure. Okay, so you are having RGB, right? So RGB is there, right? So you can see that RGB. So here, once this is for R, this matrix, you can see that this matrix is R, right? This matrix, you can see that this is for R matrix, right? You are having the pixels that indicates this is for R color, this is for R color, right? This is for R matrix. And one layer back to this layer, you are having another matrix, right? This layer is for a green matrix. This one is for green matrix, is there, right? This one is for green matrix, actually. This one is for green matrix. This one is for green matrix, and this one is for blue matrix, right? You are having multiple values over there, right? You got an idea, right? So one stacked another, right? So 3 layers are stacked one before that, right? So RGB matrix is there. Can you imagine that 224 into 224 into 3? Is that okay? Right. My question is that once we have this 224 into 2, initially you have 224 into 224 along with 3 by 3. Now you have 224 into 224 3 and along with the 3 by 3. So what will be the output dimension? Okay, so you can imagine that this 3 by 3, this 3 by 3, this 3 by 3 will move from left to right, top to bottom, left to right, top to bottom, right? So this will go in this fashion, right? This will go in this fashion, right? So what will be the output dimension? Output will be the dimension. So you can see that I will give you some options. Okay, I will give you some options. Option A, like a Crorpadi program. I'm giving you some option. Okay, option A, 220. Like previously we had 222 into 222, right? So 222 into 222. Option A. Option B, 222 into 222 into 3. Okay. 220, you know the equation, right? Input minus something plus 1. Let it be the normal equation. So this be 222 without any stride or padding. You know this equation, right? The 222. So can you spell out which is option A or option B is correct? Will be the correct one. Can you tell me? Okay. I'm reading your chat. Okay. Please go through the chat because this learning is very much important. Okay. Yeah. B. Okay. Okay. I'm reading your chats. Let you please chat. I let me drink some water. Okay. Any other answers? We have 296 participants from this great India, but I am having the 10 chats only. Okay. Everyone is here, right? Okay. Then can you tell me any other? Yeah, two. Okay, option B. Everyone is telling the answer option B. Okay, very interesting. Anyone having the option A? Anyone having the option A? Okay. Yes, I have option A. I belong to option A. Okay, dear participants, I belong to option A. You are all telling about option B. I stand strong with the option A. Can you tell me the reason actually? You'll be wondering that you will be giving. I know why you are thinking about option B because this is 3-channel depth, right? Can you tell me? Can I show you how option A is the right answer? Let me show you. See, you can see that. Please listen me. You can see that. No, only one kernel means, yeah, that doesn't matter. Okay, only one kernel is the right answer. But how it looks like is like, for example, the 3 by 3, this 3 by 3 initially will pass through this R matrix, right? This R matrix, the first layer, which is stacked on the top, right? So finally, it will generate a matrix called, see, I'm drawing a reduced representation so that everyone can easily. So when I'm passing this 3 by 3 through the R matrix, I will be getting the dimension, as you have said, 222 into 222. Yeah, you have pointed out the same way, right? 222 into 222. Fine, that's okay. Again, I am passing this matrix through the G layer, right? Through the G layer. Is that fine? Through the G layer. There also, this is for R, right? This when I have passed through R, right? This when I pass through R. Again, I am passing through the G matrix, and finally, I am getting another matrix from there. That is G matrix, right? That is G matrix. That is G matrix, right? G matrix. Here you can see that G matrix is there, right? G matrix is there. Okay. And finally, again, I think you are getting, you will be, the answer you have, your answer is correct, right? Right? Let it be again. This, when I'm passing the filter through the blue matrix, I will be having this another one, right? Another one. Okay. Please excuse for the delays in between because this is a must pain, right? Okay. If in the classroom we will be drawing in the board, okay. I think it's the end of the pain, right? Give me 1 second. Okay. Okay, so you can see that this is again 220, and you will be wondering that it will be 222 into 222 into 3, right? That's why your answer option B, right? So, but how it will look like is that, see, you can see that, you can zoom out, right? You can see that here. You can see that the first pixels of RGB, right? Sorry, again, 1 second. The first pixel, 1 second, I will take that. The first pixel of R, G, and B is there, right? It will be added together. It will be added together. Okay. It will be added together. It will be added together. And the output you have generated here is in this way only, right? So you will be wondering that it will be stacked one by one, but the corresponding pixels, the first pixel in the R and the G and B will be constituting the first layer output in the final output, right? First neuron in the first layer, first pixel in the output, right? So hope you got that, right? Similarly, the 220 into 222 pixels will be added together, and finally you will be getting the dimension. Which one? 222 into 222. Is that okay? Instead of 222 into 222 into 3. So dear participants, is that okay? How you got the first result? 222 into 222. So the main point is that, so this you will get idea only by continuously reading the textbooks line by line or between the lines, okay? So is that okay? Why it becomes 222 into 222? Can you chat me, everyone? Can you chat? Yes, right? Okay, so that's the reason. Yeah, I'm giving you some insights which I have read from the very other textbook. And is that okay? Please take care of some notes. Okay, please write it down. I know that you need to have some time because in chat in between the break time I discuss with my some of the participants, and I think you need to have some time. Need to have some time to write this, right? Okay, please write it down. So two cases I have explained, right? One is a case when 224 into 224. Now the case is 224 into 224 into 3. In very much detail, we are explaining CNN now. Okay. instead of just going through a glimpse over the CNN, I am detailedly going through each and every phases. Okay. So if you have this strong base, you will be exploring much more in the AlexNet, VGGNet, RusNet, XOR, blah blah, all these net you are having. Okay, I know that everyone is experimenting. We will be having experiment. I mean, some research scholars are doing this one. I mean, some are from electrical, electronics, civil background. They are just applying AlexNet, VGG, RusNet. Is that right? So, but if you have the after this class, you will be getting an idea that how each and every layer is processing the data. What will be the output dimension to look like? Okay, so once you got this strong idea and idea strongly, you will be easier that you could explore each and every layers of AlexNet, VGNet, RusNet, and you could design your own model. Right? That's where I'm okay. Is that okay? It's clear, right? It's clear, right? So can I am taking that this is case 1 and this is case 2 now, right? I'm taking that this is case 2. Can I go to the case 3? Can I go to the, I think it's very clear to you, right? I'm going to the case 3. The case 3 is that you can see that here you got an idea that 224 into 224 into is multiplied with the 3 by 3. Here, not multiplied, it's convolutionally operational performed, right? Here, 224 into 224 is 3. When I apply with the 3 by 3, what will be the output? Now I am going to explain. If I am applying 32 such filters, okay, 32 such filters, what will be the output? Okay, 32 such filters, what will be the output? Okay, 32 such filters, what will be the output? Okay, so is that clear, right? So you will be wondering that why we require 32 such filters. Can anyone tell me? So that's why I have mentioned it already in the first 1 hour. Okay, can anyone tell me? Hope you please recollect or remember why we require multiple such kind of, for example, 32 or 64. Why we require multiple filters for that? Sometime I could give 64 into 3 by 3, right? Sometime I could give 120 such 3 by 3 filters, right? So what is the need of having these filters, multiple filters? My first question is, what is having the need of having this multiple filters? Can anyone? You remember, yeah, you'll be remembering that this one, right? This, you hope you remember this one, right? You will be having the need of, yeah, to extract the multiple features and to reduce the error, right? To recognize a digit properly or recognize a feature or an image properly, right? And you can see that for identifying this coil, you need multiple detectors, right? You require multiple features to identify that. For example, 9 or 6 or 8 or 96, you require multiple features so that this loopy pattern, this, for example, this is a simple digit. It only having loopy pattern, it only having the diagonal pattern, right? But in the case of an image, it may having multiple. For example, I am capturing a photo of mine. So my photo is there and it is a red color or it's a colored image. And you can see that it may having different kind of features, right? So to identify all these kind of features, depending upon the data set, we should explicitly mention what is the number of features we should take care, right? So now we are going, I'm blindly telling that I have 32 such features, okay? Sometimes if it is a complex data, I mean complex data in the sense means we require multiple features to identify that image, right? So if I having 32 into 3 by 3, what will be the result? Okay, so can we go to the max again? So let it be 224 into 224 into 3 and 32 into 3 by 3, right? So already we have seen that 1 into 3 by 3, right? The case when we having 1 into 3 by 3, right? So you have seen the idea, right? 1 into 3 by 3, right? 1 into 3 by 3. Now you have seen 222 into 222 we have produced, right? 222 into 222 we have produced. So again, I'm giving you option like a, so we are going to the Crore episode again. So the options are 222 into 222. Okay, 222 into 222 again. 222 into 222 into 3, 222 into 222 into 32. Okay, so what will be the dimension? The question is, I can explain, repeat the question again. For example, I have an image with the 224 into 224 into 3, and I am applying a 3 by 3 filter. Not one 3 by 3 filter, I am applying 32 such filters. Already you have seen the output dimension when you have applied one 3 by 3 such filter. So can you tell me the options, like your options are available to the right side of your screen? Okay, so please Press the buzzer button. One option A, option B, option C. Can anyone tell me the answer? This time. Okay, this is the case 3. Okay, this is the case 3. Option, we have again 300 participants from India, this great India. Only 3 or 4 chats are there. Okay. Option C, somebody is filling option 1. Somebody is filling option 3. Okay. Yeah, Sabina ma'am is there, option 3. Okay. Right? Disha GS. I know, ma'am. See, okay. So the option again, this time you have won the competition and you got a prize of 10,000 rupees. Okay. So this time you have won. Last time I have won. Okay. So the answer is 222. Yeah, 224. How you know that, right? So if I apply this one filter will again, if you are applying 32 such filters, okay. The 32 such filters means it will come back to back, right? Back to back in this fashion, right? In this manner or in this fashion, it will go around, right? So 32 such filters will happen. 32 such layers will be producing stacked by stack, right? Back to back. So is that okay? My dear participants, somebody or already know the concept, somebody or beginner into the concept. So everyone, can you chat me frankly from your heart that is that clear to you? These 3 cases, case 1 and in case 1 also we have seen 4 scenarios, right? In case 2 and case 3, is that clear to you, dear participants? Can you chat me, please? Everyone. At least 10 chats is enough. Okay. Right. Okay. So this is a basic way the convolution has been performed. Is that clear? Right. Okay. So if it is clear to you, I'm very happy that. Okay. So that is the relevance of having. So again, I'm repeating. We have seen the fundamental case, the basic case, when one filter size is applied, and that time we have seen 4 scenarios. Simple case with the padding, with the striding, with the padding and striding. So 4 scenarios we have seen. Then a case 2 we have seen. This time we have applied 3 channels, and case 3 the 3 channels along with the multiple filters. Is that okay? So if that clear means we will stop a convolution layer here. Right? Now we are jumping to the next layer, which is very easy comparing with the convolution layer because this is not much complex that of convolution layer, right? So you have seen the convolution layer, right? So my dear participants, can you tell me what will be the next layer? So you remember this one, right? We started from here. Okay, we started from here. We are training the images using, initially we have a convolution layer. So you remember, after convolution layer, I'm going to mention about this one, the ReLU layer, right? So ReLU layer, let me show you actually. ReLU layer. So can you, it's very easy, not much computation is required, right? So here also, so once you have the convolution layer, you should so you know that I have an image. I passed through a convolution layer and I got this dimension. You have that dimension, you have the equation. So point number 2, I got an image from or a reduced representation or a remapped representation from convolution layer. So don't consider that after the convolution layer, I will get an image again. Okay. After the convolution layer, I will be getting an image again. I will be getting a reduced representation will be, I think I have included in the slide, like this one. I have included in the slide this one. I will show in a black and white. So after the convolution layer, the output will be look like this way. I think it's visible to you, right? Can you see me the car picture? Okay, this one, right? So after convolution layer, don't expect that I am getting another image. Okay, I will be getting the reduce that compact that represent the enough information. I mean, to represent the car, the border lines are very enough, right? Because we have, I mean, if it is a good representation, I could say that this is the best filter we have trained or generated by Keras or TensorFlow. Is that okay? So this is one output. So once I have generated an output from, so this is a matrix. Okay, this is a matrix. Point number 2, this matrix I am giving into a ReLU layer, which is very easy. Okay, in the ReLU layer. In ReLU layer, what it look like? I have seen that we have the people, right? And someone is always thinking positively only. Okay, I have a friend that everything we are manifesting and positively only, right? So if we are thinking positive, we will be getting positive things, right? Similarly, I should say that ReLU is a layer that gives the positive outputs only, because what ReLU layer do is that like it. Oh, I will show you the equation. Simply what ReLU layer is showing like that. This one. See this equation. If we have some negative values, it will be converted to 0. If we have positive values, it will be returned as that value is there. For example, the value is negative, positive 5. The value is positive 5. What will be the output? A positive 5 only. Okay, positive 5 only. If we have a value of negative 5, what will be the output? Can you chat me? If we have a value of negative 5, what will be the value? It will be, you can see this equation, right? It will be 0. So that's why I have told that this is a positive expectation layer, that is ReLU layer. It always thinks positively. Okay. So what I have obtained some metrics from convolution layer. So that layer I have obtained an output from convolution layer. So that will be passing into the ReLU layer, so that the negative values will be transformed into 0 and the positive values are returned as such. That's okay. So here you can see that the negative values are transformed into 0 and the positive values are retained such. You can see that, right? Positive values are retained such. Is that fine? So this is a case when ReLU activation function works. Okay. So once you got that, this is the idea when you need to smoothen that matrix what we have obtained. Sometimes it is the negative one means it is occupied with a positive value, means it is occupied with a pixel value. What negative values is that some blurry area is there. Some showing the blurry effect. Okay, that blurry effect is smoothed by ReLU. Okay, so you can see that. So you don't know that what will be the output after convolution layer. The convolution layer will produce some negative values also. Okay, so that time it will be blurred. The effect will be reduced by using ReLU effect. Is that clear? Hope you got the idea of ReLU function. Is that clear? Can you share me, or you may write it down? Okay, you know this equation that I have shown to you, and this one, right? So are you writing now? Please note it down there. What is a ReLU layer? Okay. So I mean, and what about the dimension? For example, the output obtained after CNN is, sorry, convolution layer is 224 into 224. What will be the output after ReLU dimension? What will be the output after ReLU dimension? What will be there after the ReLU dimension? Same, because there is no multiplication operation or reduction operation is applied, right? The output will be the same. That's the point. You can note it down. Okay, there will be no reduction change after ReLU activation function. Okay, so hope you got what is convolution layer and what is ReLU layer. Is that okay? Right. So once you have that ReLU layer output, you can see that the next layer is pooling layer, right? Pooling layer. What pooling layer does is like it will reduce the image into smaller size. Okay, it will reduce the image into smaller size like this. Multiple kind of pooling techniques are there. Max pooling is there, min pooling is there, and average pooling is there. Okay, max pooling, min pooling, and what? Max pooling is just like, for example, in the left side you are seeing some matrix output generated from pooling layer. Sorry, the ReLU layer. And what pooling layer is said, for example, if I'm applying max pooling, you can see that for example, I'm taking a stride of 2, 12, 28, 12. Okay, 12, 28, 12. And what is the maximum value from there? What is the maximum value obtained from there? It's actually 20, right? Maximum value is from 12, 28, 12 is 20, right? And the stride is 2, so we should think about the next 2 movements. Okay, so 30, 0, 2, 0. So the output will be 30 is the maximum value, right? And again, stride is equal to 2, so it will be 2, right? Here also the value is 79. Here the highest value is 20, right? 37, right? So 12. So hope you got what is max pooling. If I'm taking the average pooling, out of the average of 12, 28, and 12 is 30. Average of 30 and 2 divided by 4, 8. You can see that average, right? So is that clear? Is that clear? Any chat? Or you may note it down, right? It's a case of pooling there, right? Yeah, you may note it down. Right. Okay. So the size will be decreased, right? Size will be decreased, right? Here, the same equation, input to minus the same equation. You can reduce that the size divided by the stride actually. So it is 4 by 4 divided by 2 is 2 by 2, right? So it is dividing by the stride will give the new dimension values. Okay. 8 by 2 is 4 because the stride size is 2. Okay. So you can see that what happened is like we have a digit, and we perform the convolution layer. then yeah, you can see that the dimension is this one, right? The convolution layer. The convolution layer is there, and the once output obtained from the convolution layer is passed to the ReLU layer, and once you apply the max pooling, the dimension will be looking like this, right? So this is a case when we're having multiple layers, right? So hope you got convolution layer, and you have traveled along with me, right? Along for the convolution layer, ReLU layer, and pooling layer. Right? We made a journey from these three layers, right? So once we have the pooling layer, you will be having this one, right? And max pooling, sum pooling, and the benefits of pooling includes this one. You may note it down. The reduces dimension. What I have told is like the benefits. It reduces the dimension. Okay, reduces the dimension. And my dear participants, can anyone tell me what is overfitting? What is overfitting? Yeah, somebody is asking that strides can be changed during. See, once we fix some set of parameter, learning rate, epoch number of epochs, I mean number of iterations, let it be mini batch size, the optimizer. This should be ensured throughout the entire training. I mean, for example, if I'm giving epoch is equal to 10 and the training may happen for 10 epochs, this should ensure for these 10 epochs. Okay. So this cannot be changed. After that, if you're going for some parameter tuning or the next set of experiment only, we will be able to change the stride. Okay. So throughout the experiment, we should keep that. Okay. Divya, madam, is that okay? Professor Divya, it's clear, right? And what about overfitting? Can anyone tell me? Give your voice or can we chat me? Overfitting. Overfitting. See, after this theory part, again, I will give you a break, okay? Before getting into jumping into the hands-on session. Yes, you should know about before. You know that this deep learning is a vast topic. Apart from CNN, some fundamentals are there. You should know about overfitting, underfitting, a regularizer, okay, optimizer. A lot of techniques are there. Okay, I will give you some example in a simplest way. See, we have some data. We need to train the data using a model. Okay, some model we need to pick up and we need to train that data. That model should be compatible with the data. For example, we are training. For example, the data points are the 10th students. Okay, 10th standard students. Okay, 10th standard students. Okay, right. Okay. For training the 10th standard students, I'm interviewing a person and for example, B.Ed is enough, right? B.Ed is enough. So I am a B.Ed qualified teacher to train the 10th standard student. It's a normal fit. Okay. But see, again, for the 10th standard student, I am using a model. I am using a model. I mean, for example, I am importing a teacher from MIT, okay, in America. Okay. He is postgraduate, postdoc fellow. See, that 10 number of students, see, teaching that 10 number of students is, I mean, that B.Ed teacher is enough, right? But if you're training the data using a higher model, okay, higher model, that may lead to overfitting. Okay, higher model, that may lead to. And again, another case, another situation. For the same 10th standard students, for example, there is a teacher who is able to teach only 4th standard students, okay? I mean, if I'm importing that teacher to the 10th standard, it will may result to some issues, right? So that is called underfitting. See, more fitting means, for example, we are training the model again and again and again and again and again, and you can see that. See, by doing the hands-on, I will tell that there are two types: training accuracy and validation accuracy. Okay, every time we are discussing the classroom, what is the difference between training accuracy and validation accuracy? That I will show you. Okay, so we will be teaching again and again. So if we call a postdoc fellow to the 10th standard, you can see that the class is very good. You will be getting wonderful feedbacks. Okay, that means training accuracy is good. But when the same students are going for the exam, they will fail. Okay, I mean the same data is experimenting with a real-time scenario, the model will fail. I mean the data set is not able to recognize. Okay, that situation. So overfitting, how we recognize overfitting is that the symptoms are high training accuracy and less validation accuracy. Training accuracy means how it behaves with our same data. Validation accuracy means how the model behaves with the another set of data. So the problem is that if you have a large number of parameters again, so we are continuously, for example, we are torturing a student again and by continuously teaching for 24 hours, he will be saturated, right? Similarly, if you're training a model with having more number of parameters, it will be having good training accuracy, but he will fail in exam. I mean, the real-time scenario. Similarly, the training parameters, we need to reduce the overfitting scenario. I mean, the training should be, it should be in a modulated way, right? So if you're taking the class in a classroom, I will show you with good examples. Okay, now you take care that if there is a model with some large number of more number of parameters more than what we require, so that may lead to overfitting. Since the pooling is reducing the dimension, right? Since the pooling is reducing the dimension means the number of weights required for that layer is get reduced, right? So since the dimension is reduced, there is a chance that the parameter is reduced. So hence overfitting is a chance of reducing, right? So as I have seen in the chat box, it's very clear. Overfitting is good accuracy with the training data, but in failing with the valuable data. Modern learn to too much, that is unable to predict a new data, that is overfitting. Okay, is that clear? So that's the benefit of pooling. So finally, once we having all these layers, the main point, please hear from take it here. Once you have all these layers, right? You have all these layers, right? You have all these layers, and you can see that you will be having a matrix generated from here, right? So I'm going to explain a very important concept. Once you have that matrix, you will be generating a matrix from there, right? Once you generate a matrix from there, you can pass it to, you will be aware about machine learning classifiers, right? You can pass it to SVM. Hope you have heard about that, right? SVM, support vector machine. There is another concept called a decision tree. There is another concept called a naive. So XGBoost is there, right? CATBoost is there. A lot of algorithms are there. So these are all classifiers. So once you extracted the features from these layers, you can pass that layer to another classifier. Okay, another classifier, and we can see how that extracted features behave that classifier. Okay, that way you could try, and that we will call as transfer learning. I will show you here from this area. You could use an SVM instead of this. Okay, you could use a neural network like this, right? Okay, so this is called a transfer learning. So what my key point is that you could use that way, and that process called transfer learning. Now we are not going to explain about transfer learning. How deep neural network works is that, see, once we extract the features, we are creating a neural network here. This is called a dense neural network. Okay, dense neural network. So hope you have the previous sessions from the experts on the previous day. You will be having input layer. This is the hidden layer 1. This is hidden layer 2, and this is the output layer. This is the output layer, right? And you can see that in output layer, in output layer, in output layer, you can see that number of neurons plays an important role. Okay, number of neurons. Can anyone tell me what is the number of neurons which we required at the end of the layer? Let me see the charts. Let me see the chart. 3. Why 3? I mean, why 3? Can anyone tell me what is the number of neurons we require at the, see, this is our example, right? So let me, so here you can see that multiple, see here only one neuron is there, let it be there. So now you 3 or yeah, can anyone tell me why is the reason specifically? Can anyone? What is the reason behind that? Number of neurons at the output layer is very critical, very important, very important while we're designing a CNN model. Can anyone share me? Depends upon the number of classes. Yes, depends upon the number. So you got the idea. You have the idea, right? I think you are all know with the CNN concepts, right? So it depends upon the classes we are going to train. For example, if I'm training with the boys or girls only, the number of neurons will be 2. And if I'm training with the 10 classes, the number of classes neurons will be 10, right? If I'm training, is that clear? And please ensure, this is a vital point. You should apply an activation function called softmax. I think someone, do you know the concept of activation functions? I'm not going into depth in detail because it will take another time. What are all these activation functions? Okay, so can anyone tell me? Hope you got it. So please ensure that softmax should be ensured at the last layer if we are placing the number of classes. You know that 3 classes. So you are placing 3 neurons. So if you're placing the neurons count as same as that of the classes count of the classes, please ensure softmax. Okay, so this is a tip I am giving to you. We could use another function also that I will explain. Okay, is that clear? Softmax is there, right? Okay, and this is the case of output layer, right? This is a case of output layer. And what about the case of this input layer? Number of neurons we require there, right? So what we are happy, what is actually happens there is like, for example, the output vector what we have obtained here, let it be, not it's exactly, let it be 10 by 10, 10 by 10, 10 by 10. What we are going to do is like, we are performing an operation called flatten, flatten, yeah, flatten, flatten. So once we flatten, the output will be, the 10 by 10 will be converted into 100 by 1, 100 by 1, 10 by 10. So you left it to right, all these fixed values are in top-down fashion, and it will be 100 by 1. So that will be the dimension over here, right? So after that, is it clear? Can you share me? So please at least chat for this also. What happens in the input layer? The output from the previous layers, let it be 10 by 10 or a 10 by 10 by 3. Let it be 10 by 10 by 3. So the output will be 10 into 10 into 3, 100 into 3, 300 cross 1. Can you chat me? Is that okay? Is that point clear to you? What happens when we flatten a layer, flatten an output? Can you chat me? Is that fine? So that will be the dimension to the input layer. That will be the dimension to the. So you know the concept of number of neurons you record in the input layer, number of neurons you record in the output layer, right? And what about the hidden layers in between? H1 is there, sometime H2 and H2, etc. up to H5 is there. So can you tell me what will be the reason? How we could? So my suggestion is like, you have used a 300 neuron, you reduce to 100, you reduce to 50, so you reduce finally to 3. So use some layer that having neuron 100 neuron. Next layer you may place them 50. I mean, you could substantially reduce. Okay, then finally you arrange a 3. Okay, don't suddenly have a far sudden. Okay, don't have a far sudden, because the features will be lost. The same thing you could after 300 you could directly use a 3 by 3, right? But the features all will be lost, right? Mapping a 300 to 3 immediately, and subsequently you are reducing to 100 and to 50 and 3 makes some difference, right? That makes some sense. Okay, so you please add some layers that make a substantially reduction over the layers. Okay, finally you made. So my dear participants, first question, is that clear? The number of neurons in input layer? Is that clear? The number of neurons in output layer? Is that clear? The number of neurons in the hidden layers? So it's all about trial and experiments in hidden layer. Is that clear? Can you share me? Everyone? Yes, right. So once you have that, yes, once you have that, so it's up to you. For example, Akshay is designing a CNN. Jishamada is designing a CNN. Megha ma'am is designing. So see how our CNN differs. Yeah, it's because of the architecture what we are proposing, and how we could suggest that. But yeah, it's based on the data set how we are going to train, right? And finally, for the data set, my assumption on these neurons might be wrong. So we should get an assumption that we should perform some hyperparameter tuning, so that for this particular data set, this much of combination, the number of neuron, the activation, the optimizer, the regularizer, what we are picking, it will go, the keras and TensorFlow will go for each and every the possibilities, and will present the right set of architecture that may generate the best accuracy. Is that clear? So this is all about. In between, one add-on thing, you can see that weight updations are there, right? To my dear participants, please go through neural networks. So that is a prerequisite you require. So that weight updation you require that, and it will iterate again and again, and finally you may reach the best set of things. So is that okay? So how this is how CNN works. Okay. So finally you can see that once you flatten all these, finally you could. So is that clear? Right. Oh, if it is clear, I think we will take. Can you? Is that clear? Can you tell me? Is the entire architecture is that clear? So this is the entire architecture. See, trust me, this is not going to explain this much of detail in textbook. Okay. This is the finest way we have presented in this way, so that everyone can understood in the simplest way. Is that clear? Can you tell me? Convolution layer, max pooling layer, fully connected. The relevance of fully connected layer, right? and finally the placing the number of neurons in the output layer, right? Okay. So if it is clear, now we can move to the hands-on part. I have added all these things in the PPT. Along with that, you could try with me. I think we can again take a 5 minutes break because I know that you are continuously stretching out in the screens. Okay. So now we take a break again. We'll start with 8:30. Coordinators, is that okay? It is 30 minutes enough to do the coding. Okay. I will explain it in a needful way. So we will join back after 5 minutes. Okay. Okay. So thank you. Please listen. I think it's useful to you, right? Thank you. 5 minutes. Okay. Is it audible? Shall we start? Sorry, I have not started. Is it audible? Yes, right.
Yes, sir.
Okay. So we are moving to the hands-on part and last part of our session. So okay. So thank you for patiently hearing me for the last few hours. So let me start sharing the screen. And so can anyone how you opened your collab? Can you share me how you opened your collab? Okay, so please open up. You can see my screen, and I will quickly go through what I'm going to do now. So this is a data set where, so this we studied KCNN, so that's a fundamental way we should know, and then we need to hands on it, and this is through an immense data set. So after that only you can jump to the bigger data set later. Okay, so we are growing like a baby. Okay, okay, so you can see my screen. One second, let me share the screen. So here you can see my screen. Okay. So we are going in right studies. Right? So you can see that. See what I'm going to experiment. I'm going to show the CNN on MMS data set. Okay. So this only after this only it's good to jump to a bigger data set. Okay. Okay. So if we have one more session tomorrow, I will show you how we do some classification on a bigger data set. Okay. So here, what we are going to do, MNS dataset is like, see, MNS dataset is a dataset that comprises of images that from 0 to 9, okay, 0 to 9 images. Okay. So how many classes will be there? 10 classes will be there, 10 classes will be there. So the images will be from 0 to 9, and there are totally, so what I'm going to show you is like, first step is to load the MNS dataset, how I will show you how to load the dataset, then convert it into one channel. So what's the requirement of one channel is I will explain you later, and what's the need of normalization or does it require? Okay, I will explain. So anyway, how to what is all about MNS is like, so we have 70,000 emails. Okay, we have 70,000 emails totally, and you can see that the 60,000 emails are already reserved for training, and 10,000 emails are reserved for testing actually. Okay, so 60,000 emails are reserved for training, and the 10,000 emails are reserved for training and testing. So 60,000 images, how to load them. So you can see that how to load is like, so again, how you know about, how you know about cross validation? Cross validation. So if I need to explain it again, it will take another time. Okay. So anyway, those who know cross validation, can you chat me in the chat box like this? Oh, is that audible? Oh, okay. It's audible. It's audible. Okay. Am I more audible now? Clear now? More clear now? Is it clear? Right. Okay. So you might be heard about yeah. Yeah, you might be heard about this one. So again, I'm repeating so quickly. So we need to dot an MNS dataset. MNS is a standard dataset. So it's a dataset which comprises of digits, which is from 0 to 9. Yeah, 0 to 9, and total number of images is 70,000. And you might be heard about training and testing, right? So 60,000 images are reserved for training and 10,000 images are reserved for testing. I'm not going to explain about cross validation because it's a bigger. I mean, I need again 30 minutes for explaining that. And you please explain. I will show you. So here you just load the dataset using keras loaded datasets.mns, which is a symbol. Before that, we should load keras. Okay, that I will show you. So to load the dataset, it's easy. Keras loaded datasets.mns. Okay, so there you could load all this dataset into a single variable, mnstdb. You can see that you can use a, b, or a or b or c or okay anything you can do, and you can use that. And you will be knowing that Java programming is there, Python programming is there, C programming is there. Can you imagine that loading these kind of images into a single variable in C programming? Is it possible? Not possible, right? So that's the simplicity of Python. Everybody is telling that Java is simple and powerful, but Python is actually simple and powerful because it has some multiple functionalities, flexibilities to handle all this kind of data, because we can load the entire data into images into a single variable, right? That's not a simple thing. And second line, you can see that load underscore data. See what extrain, y train, access, y touch is that you can see that here in this manner the data will be looking like. So the 60,000 data, the images, we can call it as X train. Okay, 60,000. See, I'm going with an assumption that you know cross validation and how to calculate the accuracy. Okay, so the entire 60,000 images, we can call it as X train. So you can see that the dimension will be 60,000 such images, right? 60,000 such images, right? And along with that, for example, the first image, you know that 60,000 images are there, right? And the first image I am labeling it as 0, and another image it will be labeling it as 5. So all these 60,000 images are labeled, right? All these 60,000 images are labeled from 0 to 9, and you can see that this is a single column vector. Okay, this is a single column vector, and this is a single column vector, right? So this is a single column vector, and you would be having this idea, right? Again, for the testing purpose, 10,000 images are reserved, and in the that is called the X test, and the corresponding value, I mean, all these 10,000 images are labeled, right? All these, whether it is 0 to 9, right? So it is labeled properly. So that is the idea. So hope you got the idea. Can you chat me? Is that this data set organization is clear to you? The data set, what X train look like, X test look like, Y train look like, Y test look like. So these 4 times, right? So hope you got that. And coming to the database size, data set size, this one, first one, I am training the printing the size of X train. Okay. Y test is somebody is asking. It is, oh, this is a mistake. Okay, thank you. This is 10,000 actually. Okay, 10,000. Thank you for pointing out. Akshay, thank you. So 10,000. Okay, Professor Akshay, thank you. So 10,000 levels, right? So is that clear, everyone? So let me print the size of or shape of that one, right? Okay, X train. So you know that 60,000 images are there. 60,000 images are there, and you can see that when we're printing the shape, okay, each and every images are belonging to 28 into 28, okay, 28 into, so the shape will be 60, I mean the shape of that variable, okay, so 60,000 into 28 into 28, is that right? So can anyone tell me, if so, what will be the shape of that X test? Shape of that X test? Shape of that X test? It will be, can you, if it is, if you can chat in the chat box, I'm very happy. 10,000 into, can you tell me? 10,000 into 28 into 28, right? 28 into 28, right? So similarly, what will be the dimension of Y train? It will be 60,000 into, can anyone tell me? 60,000 into 1, right? And this will be 10,000 into 1, right? Is that clear? Right. So this will be the shape you could produce there. 60,000 28 into 28, 10,000 28 into 28, 60,000 and 10,000. Is that clear to you, dear participants? Right. So, then, if you want to see some image, you can use a function called PLT. So PLT is a package. We will call it as matplotlib.pyplot. Okay, matplotlib.pyplot. Okay, so that we will show. Okay, so matplot will be, so using a function called imshow, you can see that X train of, you can see that X train of 60,000 images are there, right? 60,000. If you want to print the first image, X train of 0. Okay, X train of 0 is there, right? And the color map, you know that if we are not giving the color map also, it will be printing there properly. To just to show you that this is a binary image or a black and white image, I am mentioning specifically that CMAP is equal to binary. Okay, so plt.im show X train of 0. That's fine, right? Okay, so you can see a first image. We will going to implement this one now. And if you want to see another image, 33,000 image, you can show that, right? Okay. And like similar way. And this next step, is that clear? So is that clear, dear participants? X train, X test, Y train, Y test, and the dimensions. Is that clear? Can you chat me? Is that clear? Right. So if you are going, if you are clear, then we are going to the next part. Okay. So this one, convert it into one channel. Why we require convert into one channel? This is a very, very creamy part of the class session today. Convolution layer, you can see that this is the first layer. Okay, this is the image we are giving. Okay, this is the image we are giving. So when you are feeding an image into the first layer, I mean first the convolution layer, we have already seen all the philosophies behind that convolution operation, right? If you are giving that images to the convolution layer, the convolution function always expect a 4D tensor. Okay, this is not mentioned in most of the textbooks. It always expect a 4D tensor. When this I am telling in the implementation side. Okay, 4D tensor. See, 4D tensor, you can see that initially the X train is 60,028 into 28, right? 28 into 28, right? But we can make it as a 4 shape, 60,000 into 28 into 1. So that we can perform using a concept called the reshape, dot reshape, okay, reshape. So that 60,000 into 28 into 28 will be converted into 68 into 28 into 1, okay. You know the dimension of X test. It is 10,000 into 28 into 28. It was, okay. Now we reshaped into 10,000 into 28 into 1, okay. So because the convolution layer always expect a 4D tensor, okay. So that's a way we should flatten this way into the convolution layer, okay. This will happen in that way. And so now I'm mentioning about the variable, okay. This I'm telling about the variable, okay. So in that way it will happen. So finally, if you require to float, it is not an option. It is an optional one. So we could normalize it in that way. Normalize means you know that all the pixels in that matrix is in the range of 0 to 255. I can see that the matrix here, right? The images will be in the value of 0 to 255. For example, there is a pixel value 255. If you are dividing with the 255, what will be the value? It will be 1, right? And if I am dividing with the 0 with the 255, it will be 0, right? So this pixel values ranges from ranges from 0 to 1, right? Because we are dividing all these values with the 255. So this is called a normalization, mapping up of the data to a common range. That is called a normal. Different type of normalization is there. Min-max normalization is there, right? So we could. This is an optional one. What is the need of normalization? Can anyone? See, the need of normalization is to see if you are reducing the pixel values which were available in 20 to 255, and if you are reducing it to 0 to 1 means the computation time will reduce substantially, okay, because we are performing convolution layer, ReLU layer, pooling layer, and doing multiplying. So it is producing another. You have seen the multiplication part in the previous session, right? So it will take more time. So to reduce the computation also, this will help you, right? So this is the idea behind. So once you train it, and so once you flatten it and you can print the shape, you can see that it is represented. So here we are going to do the hands-on. Dear participants, this is an example of convenant, which is an example of a convolution layer, and you can see that. See, this is the climax portion of our session today. Okay, so please take care of the climax. Okay, the climax is very important. Like a film, the climax is very important. So we have an image 228 into 28 into 1, right? Single image. We are designing a CNN such that convolution layer followed by a convolution layer, followed by max pooling layer, followed by dropout. I missed out actually. So what dropout then do is like it will cancel. It will. I mean, so we are switch on and switch off the light or fan or TV, right? So similarly, if you are applying dropout 0.25 means the 25% of the previous output will be discarded. I mean, the random 25%. I mean, we are generating some matrix here, right? So 25% of the previous output will be, the pixels will be discarded, right? So that it will reduce the concept called overfitting. It will reduce the concept called overfitting, right? And after that, we are applying the flattened layer. Then I have mentioned the dense layer, again a dropout layer. Finally, we are applying the last layer, that is called a dense layer. I mean, whatever the neural network layer we are creating is called a dense layer. So in the previous session, I have mentioned that we should substantially reduce, right, after flattening. Anyone remember that? After flattening, we should substantially reduce this one, right? And after that, finally, we are converging, dropout, applying, and finally, we are number of neurons is 10, right? What is the difference? What is the need of having that 10 neuron? You know that number of classes, right? So if we have an architecture like this, how we are going to implement this? This is the finest way I'm going to explain. Please take it. Is it clear? I'm going to use a CNN, the architecture. And if you have an architect, such an architecture, how to design that, please take it. There is a concept called keras. There is a package. So we are going to start from here. The first step is the keras, loading the keras. Second one, you need to design the convolution, first convolution layer, right? How first convolution layer is keras.layers.conv2d. So this is a conv2d layer, right? And you can see that. 32 such filters are there. You remember that, right? I have explained it in detail in a bigger way, in the bigger picture, and I have explained in the previous slide, right? Previous session. 32 such 3x3 filters are there, right? So that is 32 3x3. And I am applying a ReLU layer. Activation is equal to ReLU. And input shape, I could directly give 28 into 28 but I am mentioning, so every time the data might not be 28 into 28, right? Sometimes it will be vary, right? Depends upon the data set what we are having, right? So why I am giving the input shape is equal to extrain dot shape 1 comma, you can see that extrain dot shape, you can see that extrain dot shape is 60,028 1. So like in a matrix, this will be 0, 1, 2. You know what array indexes, right? The array indexes will be 0, right? So I am taking extrain shape is 60,000 into 28 into 21, but I am taking this 28. I require this one only, 28, 28, 1. So it starts from 1, right? Extrain of 1 only. So extrain of 1 I require, extrain of 2 I require, extrain of 3 I require. So that I will be getting 28, 28, 28. Extrain of 0 I don't require because it is 60,000, right? So from extrain of 1 I require, that's why I'm using extrain of 1 colon. Extrain of 1 colon. You can see that, right? This is 1 colon. Is that clear? Can you chat me? Is that okay? Can you chat me? This is the finest way. So this is the way we could add the layer, right? Can you tell me how I represent it? So this is keras dot layers dot conv 2D 32 3 by 3. Activation is relative input shape. And this one, initially we created a dummy variable, an object we can call, and there we are adding. We are appending the first layer. Is that clear? Can you share me the layer explanation, how we could perform using keras? The keras explanation for this layer at a glimpse. Can you share me quickly? We have 10 more minutes, quickly. No one? Okay, I'm jumping to that. Please go through that. Okay. So please go through that again. And what about the second layer? This second layer I'm adding. Keras dot layers dot convey 2D. There we are adding 64 3 by 3. Activation is equal to use this one, right? And you can simply see all these functions are available in keras, which is very easy. Okay. So this one, keras dot layers dot max pooling 2D off. Max pooling 2D off. Max pooling 2D off 2 by 2. Okay. And then we are adding a dropout layer. Keras dot layers dot dropout of. Dropout of. You can see that 0.25, right? And then I am adding a flatten layer. Functions are there. Keras dot layers dot flatten off. Then I am adding a dense layer with the. Now I have flattened that, right? Flattened that. So I have flattened that. Then I am using a layer 128. So keras dot layers dot dense of 128 with activation function relu. Okay. Then I am applying a dropout layer. Keras dot layers dot dropout of 0.25. Finally, I am adding a dense layer with the 10 neurons and softmax function. Is that clear? So that is the idea behind. So simply we could write using keras code. Okay, is that clear? So this is the finest way. Is that? So dear participants, shall I jump to the answer? Okay. So I think the code I'm sharing you in the chat box. Okay. So I'll be having the code one by one. I am sharing to you. So please open Google Colab. Okay. Please open Google Colab. Please open Google Colab. In 10 minutes, we'll be winding up the hands-on session. Don't worry. Okay, Google Colab. Google Colab. How many of you are doing with me parallelly? Can you tell me? Yes or no? I want to know the phase of the session. That's why. Yes, doing that, right? Okay. Normally, I take the workshop keras, deep neural network before CNN. So if you are attending, if you had some session DNN, that is very. So here I'm sharing the codes one by one. So please import that along with me. Okay. So this one you are running. Okay. Where your Google Meet is there, right? Okay. So please run along with me. Okay. Okay. So I have shared the codes in the Collab chat box. Okay. Sorry, Google Meet chat box. Okay. Please take that. So please run that. Okay. You know about Collab and running all these things. I'm not going to do that. Okay. So you know that. I'm hoping you are aware with that. Okay. Please look into my screen also. So now we are importing some packages, NumPy, Pandas, TensorFlow. You can see that this one from TensorFlow you should import. Yeah, I will share the entire because the sharing is okay, but by explaining one by one only it will be clear too, right? So please do along with me. Okay. So here also, then one. Surely I will share the page. Okay. Second one, the entire things what we have seen already, right? So please this one. Okay. Entire things we have seen in the PPT. Okay. So this one. Okay. I have already explained the PPT. Okay. I have already explained in the PPT. Sure. I will share the Python file in the group. So you can see that we have loaded the data set, we have checked the shape, so we have plotted the. So hope you got that, right? How you got this along with me? And you can check the shape along this one. Yeah, this one. Already we have explained there, right? Okay. So block, you executed block wise. Okay. I am sharing the codes in a modular way. So you are getting the outputs, right? Okay. Hope you are getting the outputs properly, right? How many have got the output so far? Right. Okay. Okay. Fine. So far we have explained the PPT in very finest way. And now I am going to design and giving you the finest CNN, the area. Already I have explained to you, right? This KRS model, conv 2D, max pooling, dropout, flatten, and all these things. And finally, you can add a summary. Okay. So let's show you that you can also check in the summary, and we need to have a discussion for 30 seconds for that. Okay. Please go through the my codes what I'm sharing. You can see here, right? How many layers are going to update? Okay. All these things. Okay. So every layers will be. If you are presenting a paper in conference, this will help you so that you will get an idea of how many parameters you have updated, right? Right. Hope you got. So, sorry. Hope you got up to this way in this to this point, right? See, I can share the entire code, but you need to run. See, what I want to convey is that you need to get the knowledge that how each block works. Okay. Surely I will share the entire code. Okay. See, if you can run it in a simple way, within 1 minute you could do that, sir. But please go through this. What I want to. Okay. Surely I will share the entire code. Okay. Okay. Now this is a part which I not explained. Okay, which I have not explained. Please take this for the next 5 minutes. Okay. Okay. See, also you can see that you have designed a model with the variable CNN model MNST. Okay, and there you could use some other function. There's a finest last way. So please focus here. There is a final code called combine. You might be heard about this C program, right? So there also you have written the code and you are generating the program. So there is a final one, combine. These three metrics are very important. Okay, these three metrics are very important. That is called the loss optimizer and what is it? Loss optimizer and this one I will show you why I will conclude in within 3-4 minutes. Okay, so you should take care about that. Okay, you should know that. See here, I explain always about DNN because we missed the class in DNN. We jumped to CNN directly. That's why you should know about this one. Okay, so give me 1 second. I will share the codes together. Okay, don't worry. The entire Python file I will be sharing to you in a single way. See, here you can see that there is a concept called compile. So compile is that, see, there are 3 parameters associated with that. Loss is there, optimizer is there, metrics. So loss means how we are estimating the accuracies and measures. See, loss is another entire topic. I required 1 more hour. So different type of loss are there. Regression loss is there, binary classification loss is there, multi-class. So since we are using classification problem, we should go for this kind of binary classification of sparse coarse entropy is there. And another one, optimizer. Optimizer is that is a one kind of module is there. So gradient descent, stochastic gradient descent, mini batch gradient, momentum, different type of add up, different type of optimizers. Optimizers is again I see each and every optimizer is requiring half hour. Okay, to explain that. Okay, so optimizer is, for example, I need to reach a point. How so? This all about the point number 1. We need the training and CNN is all about finding the best set of it or reducing the error. So that error, how we are estimating, that is estimated in loss. And then loss means we need to reduce the minimum to the minimum reach, right? So optimizer is, for example, we can reach to my college by walking, right? We can reach to the college by going into a car. we can reach to the college by going into the train, right? But how we can quickly reach that point is very critical, right? How we can quickly reach to the error, minimum error point. You can see that in the figure, you can see a minimum error point is there. So that optimizer will represent or will determine what is the way how to reach that minimum error point. So that is the need of optimizer. It's a vast topic, okay? It's a vast topic actually. So please go through that, and then metrics. This we are going to evaluate in the terms of accuracy. Okay. So this is a requirement of loss optimizer and optimizer metrics. And just I have made a, I know that I have made a glimpse only. So here you can see that when you're training a model, we should compare it. So in that compare, you should give loss optimizer and metrics. Okay. And finally, we are training the model using the X-train. You know that 60,000 images are there. Y-train, 60,000 labels are there. And here, how many iterations or how many epochs I need to give? Just I have give only one epoch, because even the single epoch is will giving much, it taking a lot of time. And what is batch size is equal to 16? How many images are there in X-train? Can you tell me how many images are in X-train? X-train total of 60,000, right? We are dividing into batches. We are dividing into batches means 60,000 divided by 16, right? That means batch size is equal to 16 doesn't mean that we are creating 16 batches, right? Each and every batches contain 16 images. Okay, each and every batches contain 16 images. So such images we are loading. I mean we are dividing it into batches, and the batches are trained together. Okay, each and every batches are trained together. So that is the requirement of batches. And finally, the test loss and test accuracy is computed by using a function called evaluate, because 60,000 X train and Y train we are training, and finally the last 10,000 X test and Y test we are going to evaluate. That's the final way we are having. So I'm giving you the final code part. So please run with me. Okay. And you can see that. Please listen to here. You can see that it is going over again and again and again. So you can see the training starts now. Okay. So you can see that 60,000 divided by 16 is 3750. So each and every image is in the 3750 is training. Okay. So this is the idea behind that. So you can see that it is getting iterated, right? See, the entire file I am sharing you to. Okay. I think how I could share? How I could share, because in Google Meet we have some limitations, right? So how I could share? So I think I can share to the organizer Iremis, and
Yes, sir.
Imran will
You
share
please
it in
send
the
it
group.
to
Okay.
me. I will share in the WhatsApp group,
Oh, okay.
or I can send his email.
Okay. Sir, can you tell me the mail ID?
I will type in the chat box.
Yes. So how many are doing? How many have started this training? Can you chat me? Because it is taking time, right? Because it will take more time, even though the epoch is one. We can give 10 epochs. Please run it and get up early tomorrow. Okay, the work will be completed. Okay. So how many can you chat me? Yes. How many are doing parallel with me? How many have started training this one? So okay, I will share to Sar's mail and Prasad sir mail, and Sar will share in group. Okay. So yeah, started sharing. Those who started the training, please give me chat in like started. Okay, so let it be run, because it will take a lot of time, because we have 70,000 images, right? 70,000 images. So this is a fundamental of how the CNN works. Okay. So I think for the last 3 hours, you are continuously hearing me. You remember? We started from somewhere else, and we have explained the CNN in a beautiful way. Each and every operations in this, you remember this one, right? The convolution operation, case 1 and case 2, and case 1 with the 4 scenarios, case 2 and case 3, number of layers, pooling layer, relative layer, output layer, number of neurons, and the output layer. Then we jumped into MNS detail, and we done the hands-on, right? So I think you please run it. Okay. So please get your results later. Okay. So it will continue. I think I can stop now. It's time. So it's very difficult to capture, pay the attention for the for a 20 minutes, right? So I know the efforts you are taking for the 3 hours and hearing my session for the day. So hopefully it is find beneficial or helpful you. Is that okay? So can you, I know that you will be recording your feedbacks in the link. Can you give me some ideas in chat box? Is that okay? How you felt? Was it useful and is it engaging? Okay, I know I'm happy to see the feedbacks in the chat box also directly. Yes, okay. So please run it. Okay, I'm reading a chat. And Prasad sir, can we stop it now for?
Yes, sir. I think there
Okay.
is no further questions. I
Yeah.
request.
Anyone have questions?
I request Assistant Professor from
Yeah, I think
FISAT.
you can see my screen, right? It went for the second depot. Sorry, I mean second batch only. And yes, so let me stop sharing the screen and hopefully it was useful for you and we will see in another session sometime. Thank you. So thank you, dear participants, and thank you, dear organizers and the management. Thank you.
Thank you, sir. I invite Professor Jismi Matthew from FISAT for vote of thanks session.
Good evening, everyone. It is my privilege to extend a vote of thanks as we conclude today's session of 6 days faculty development program on strategic approaches and emerging trends in data science. First and foremost, our sincere gratitude to our esteemed resource person, Dr. Sumod Sundar, Associate Professor, Center for Artificial Intelligence, TKM Kollam. Thank you, sir. We are grateful for the time and effort you have invested in preparing and delivering such a remarkable presentation. Your session was truly inspiring and providing us with deep knowledge of machine learning, deep learning, and reached in the convolutional neural networks and the effort of practical takeaways also. On behalf of FISAT ANGAMALY, I extend my heartfelt appreciation to our esteemed resource person, Dr. Sumod Sundar, Associate Professor, Center for Artificial Intelligence, TKM Kollam. Thank you so much, sir. I also take this opportunity to express my gratitude to all the participants who have actively engaged, asked questions, and made this session made more interactive and fruitful. Once again, thank you, Dr. Sumod, and all participants. Tomorrow's sessions will be on Framework for Deep Learning in PyTorch. The session is handled by Dr. Satyajit from IIT Palakkad. Session will be 6 to 7:30 p.m. And AI Vector Search in Oracle Database handled by Anand George, Oracle USA. Once again, thank you so much and have a great night and see you tomorrow.
Thank you.
Ini mu kore ne